Good morning, everyone. I request everybody to please settle down. On behalf of Mksss Dr. BN College of Architecture and Ferrocement Society of India, it gives me immense pleasure to welcome you all to this international conference on art, science, and technology of ferrocement construction. We are honored by presence of eminent keynote speakers, technical experts joining us globally from reputed institutions across United States, United Kingdom, Italy, and Bangladesh. Their participation marks this event as a truly international collaboration dedicated to pushing the boundaries of knowledge in ferrocement design, application, and research. As this conference is being conducted in hybrid mode, I extend my warm greetings to all the attendees, invitees, speakers, and participants who have joined us online. Across next 2 days, we will be engaged in various keynote addresses, paper presentations, live demonstrations, poster exhibition, and technical sessions, offering insight into both time-tested practices, emerging innovations in versatile and impactful material system. Before we begin the formal proceedings, I request everyone to ensure their mobiles are set on silent mode. To formally commence the 2-day journey of knowledge exchange and innovation, I invite esteemed dignitaries to the stage. Our Sanstha, Maharshi Karve Stri Shikshan Sanstha's committee member, Jayanti Namdar sir, Vice Principal Bnca, Dr. Sharvya Dhongde sir, convener of the conference, Dr. Kalyan Sundaram sir, Engineer P.P. Lele sir, Engineer Rajendra Pawar sir, who is founder of Ferrocement Society, co-convener Sujata Mehta ma'am, Professor Kanchar Atnurkar, Engineer Abu Sadiq from Bangladesh, Engineer Owen from USA, Engineer Girish Sangle from Ferrocement Society India, Vivek Bothre from Vascon Industries, Vipul Landekar from Ultratech, and architect Rajiv Raje from ESA. Please, please come on the stage. While taking blessings of Maharshi Karve to invoke blessings of Goddess Saraswati, I invite Ms. Lakshmi, student of Bnca, to present Saraswati Vandana.
शारदे पूर्ण कर कामना, शारदे पूर्ण कर कामना, ने प्रकाशाकडे जीवना, ने प्रकाशाकडे जीवना, वेद विद्यावती दे आम्हा सन्मती, हीच चरणी तुझ्या प्रार्थना, शारदे पूर्ण कर कामना, नाद प्रत्येक आहे तुझा, तूच आहेस वागेश्वरी, सूरलय ताल रूपे तुझी, तूच साक्षात रागेश्वरी, तूच साक्षात रागेश्वरी, शारदे पूर्ण कर कामना, शारदे पूर्ण कर कामना. धन्यवाद.
I request Jayanti Namdar sir and Kalyan Sundaram sir to offer the garland to the bust. Sharvya sir. Request everyone to take their seats, please, in the audience. Yes. Yes. I request everyone to please take seats in audience. Jayanti Namdar sir, you can please wait for a minute. We are pleased to have Engineer Jayanti Namdar sir, representative and managing committee member of Maharishi Karve Stri Shikshan Samstha. He has an inspiring force behind the growth of BNCA. I request Jayanti Namdar sir to brief the audience, address the audience.
सुप्रभात। मैं हमेशा मराठी या हिंदी में ही बात करता हूँ, क्योंकि मेरी समझ ये है कि इतने साल अपने को स्वतंत्र मिला है, फिर भी हम दूसरी भाषा के गुलाम हैं। तो मैं हर समय विद्यार्थियों को बोलता हूँ कि मराठी या हिंदी में बात करो। तो मैं आप सबका स्वागत करता हूँ। आज बहुत अच्छा दिन है जो अपना फेरोसीमेंट के ऊपर क्या कर सकते हैं। फ्रॉम द इंजीनियरिंग पॉइंट ऑफ व्यू, फेरोसीमेंट कैन बी यूज्ड एज ए स्ट्रक्चरल मेंबर। ओनली यू हैव टू टेक प्रॉपर प्रिकॉशन वाइल जब फेरोसीमेंट का आप कोई स्ट्रक्चरल मेंबर बना रहे हैं। तो मैं मेरे अनुभव से बोलता हूँ कि एक पूरा मरीन इंजीनियरिंग इंस्टीट्यूट का बिल्डिंग पूरा फेरोसीमेंट में किया था लॉन्ग बैक, और उसके ऊपर 8 टन का जो बोट का जो रहता है वो फेरोसीमेंट से लटका हुआ था। वो बहुत चैलेंजिंग काम था, लेकिन किया। तो फेरोसीमेंट का यूज़ सब जगह होना चाहिए। हमारी संस्था में भी मैंने फेरोसीमेंट के बहुत सारे यूज़ किए हुए हैं। तो इतना ही अभी बोलता हूँ इंट्रोडक्टरी, और सबको जो आए हुए हैं उनका स्वागत करता हूँ और आगे कार्यक्रम शुरू करने के लिए बोलता हूँ। धन्यवाद। नमस्ते।
Thank you, sir. Now I may request Engineer P.P. Lele, sir, President Ferrocement Society, to address the audience.
Good morning and I welcome you all. Today's theme of our convention is art, science and technology of ferrocement construction. When you think of anything constructing a structure, first comes architect. He designs the structure as required by the owner or whoever is using the structure. Then comes the part of engineer who designs, actually a structural designer designs it for sustainability, stability and long life of the structure. And then comes technology, how to implement that design in practice. There comes a part of site engineer, or you can call him contractor, and also technicians, masons and everything. Technology has to percolate to the bottom so that there will not be any problem later on. Now, I'll hand over to Dr. Kalyan Sundaram to speak about the progress of Ferrocement society, because in Ferrocement society, how it is formed and what we are doing in the society, and I appeal to all to become a member, and what society is doing, Sundaram sir will explain to you. Thank you very much.
Hello, good morning everybody. Good morning. Okay, thank you. All of you are eagerly waiting perhaps to understand what is Ferrocement. I understand that there is a big cross section of audience which is from KG to PG as we call it. All right. So I have made a potpourri of a, you understand what is potpourri? Not pani puri, potpourri, okay. So I have made a potpourri of a presentation for all of you. Most of you I see youngsters. We want all youngsters to become members of the, the Ferrocement Society of India. Obviously, you'll say, sir, humko milega kya? Jayant Inamdar sir will excuse me, I'm going to use a hybrid language. I'm going to use English, Hindi, Marathi, so it's going to be Hanglish Mar, whatever you call it. Okay. So, in that sense, Ferrocement is going to be the future. And I'm not just saying it, perhaps you'll remember me 20 years down the line, when you see that almost every building in this country which is progressive, okay, I'm just bracketing it, every progressive structure in this country will have Ferrocement in it. So if you want to ride the wave, you should understand and exploit this technology. We are all thinking about 2047. I work on square root consulting, a concept of trying to, if you tell me that an item can be done in 10 days, then I say, can it be done in square root of 10, which is like 2 point some days, 3 days ke andar kaam ho sakta hai kya? Can you do that same thing within 3 days? The same thing I also use for cost cutting. If a structure is done in say 100 rupees, can it be done in 10 rupees, square root of 10? Okay, people say get out. Okay, but then if it is not, if you start thinking for 10 rupees, you will end up somewhere near 50 or 40 rupees, still there is saving, and this is the scope for continuous improvement in everything. If you look at check dams, if you look at water storage areas, and if you look at small things which you see for which India and this part of the world needs, you will find the answer is in Ferrocement. Why? If you build a check dam using conventional methods, it will cost you 15 lakhs. If you build the same check dam across a 15-meter span, your guess is better than mine. It will be less than 7 lakhs. That can be demonstrated. That has been demonstrated already in a number of places. I'm going to show you pictures. So, with this, I think all of you should look forward to contributing in this area, riding the wave and becoming. Oh, we have come to Afghanistan. All right. So anyway, so we should export this technology. Not only, I always have a very favorite statement which I make. Very soon, it will be India, Pakistan, Bangladesh, Sri Lanka, which are as of today leading the world in Ferrocement. Does that demand a clap? We are leading the world in Ferrocement because the number of houses, our population is anyway 1,000 times or 10,000 times more. So we build more houses than anybody else in the world. Our experience is very good. Now the boom has come. It is time for us to show the planet where we can do and what we can do. Thank you very much. Welcome you once again. Please have a very lovely session. There are a lot of experts from all over from different countries, and we have got very senior Ferrocement society members, I don't have a beard white in color, but there are a lot of people with white beards, and you can take advantage of them and ask all the questions and learn as much as you can. Of course, last but not the least, do not miss the site visit. Okay, a picture is more than 100 words. An actual item is more than even 1,000 words. Okay, if I show you a picture of a vada and then you just touch the vada or you see the vada is another thing. But if you eat the vada, it is different. So please do not miss. Miss the. We'll have batata vada on the way in Bhugaon or wherever the site visit is. But definitely do not miss the site visit. Please register for it if you have not already missed. If you have friends, all types who would like to have picnics, please do register for it with them too. Of course, the details will be explained by further speakers around the road and in the announcements. Sujata madam will be very happy to give you more. I mean, all the volunteers will be able to give you a lot of details. Thank you very much. Jai Hind.
Thank you, sir. Now I request Dr. Sharvya Dhongde, Dr. Sujata Mehta, and Engineer P.P. Lele sir to come on dais for felicitation of the industry partners. I request Vivek Botre sir to come on the dais. Dr. Sharvya Dhongde sir, please felicitate Engineer Vivek Botre with memento. Vivek Botre sir is from Vascon Engineers who are sponsoring the event. I request Sandeep Bansal from Ultratech to come on stage. P.P. Lele sir, to please felicitate. Is Sandeep Bansal? Thank you. Sharve sir, you may be here. To set the conference tone, I invite Dr. Sujata Mehta, co-convener of this conference, to formally welcome and discuss about the themes of the conference.
Hello and a very good morning to everyone present here. A warm welcome to all of you on behalf of the organizing committee of the International Conference, Art, Science and Technology of Ferrocement Construction. Ferrocement is a remarkable union between mortar and the wire mesh. The science of ferrocement lies in its strength, resilience and cost effectiveness. The art is seen in its graceful, creative and lightweight forms. The technology is ensured by strength, innovation and sustainability. So it bridges engineering precision with architectural imagination. So that is why today, Dr. Bhanuben Nanavati, on behalf of Dr. Bhanuben Nanavati College of Architecture, I take immense pleasure to welcome you all for the international conference. This conference celebrates ferrocement as a true fusion of art, science and technology. In upcoming 3 days, we will be exploring various aspects of ferrocement construction with keynote sessions, paper presentations, exhibition, which is on the ground floor, live demonstration and site visit. Site visit will be, I hope everyone knows that the site visit will be taking place to a residential building in Bhugaon. It's an ongoing construction site, so we can learn a lot about it. You have to give names to the volunteers on the registration desk for the site visit. So without taking much time, on behalf of organizing committee, I thank you all for joining. And I will also, I'll hand over the mic to Shweta for further felicitations.
I request Jayant Inamdar sir to come on stage. Dr. Sharvya Dhongde sir, please felicitate Jayant Inamdar sir. Thank you, sir. Chief guest for today, Architect Abhay Purohit sir is here. We extend our warm welcome to you, sir. Request you to please come on dais. Dr. Anurag Kashyap sir. Please give a big round of applause. I request Kalyan Sudaram sir to please come on the stage. काय झालं? Stop. It's my honor to invite Dr. Anurag Kashyap sir, Principal Dr. BN College of Architecture Pune, a visionary academician and leader, to share his thoughts with us and address the crowd.
Good morning, all the dignitaries on the dais, in the audience. I am glad to receive you all in this very, very auspicious place founded by Maharshi Dhondo Keshav Karve way back in 1896. Bharat Ratna Maharshi Dhondo Keshav Karve founded this institute for the emancipation of women through education. And in 1994, we started Architecture College, and in last 32 years, we have been progressing. The beginning was a very humble beginning, but soon we could establish ourselves. And why I call it as a humble beginning, because whether only girls' college concept will work or not, that was the apprehension by various authorities. But my girl students, they proved that yes, only girls' college also can lead India. And we became one of the best. And now recently, a platform gave us 5th position in the world in all architecture colleges. And this happened due to technological advancements. we started India's first digital architectural technology course along with Fab Lab. Fab Lab was the first of its kind. And then later on, Microsoft HoloLens technology, experiential reality lab. And another features are we recently completed or achieved 89th international collaboration, which is, I think, a world record, that 89 international projects and international collaborations. I'll give you many occasions to clap. And we started India's first only girls drone technology institute in Bnca. So, and we have drones now. We use LiDAR, photogrammetry, and other techniques. Also, we have completed 16 international United Nations project in 16 different countries, and that's why United Nations gave us the status as a partner under United Nations Academic Impact Program. And they gave us status as the hub of United Nations to this campus as well. So yes, you can openly clap, there is no problem with so good. So before we start the program, I formally welcome President Council of Architecture Abhay Purohit sir and all the respected dignitaries on the dais. I appreciate our professor Dr. Sujata Mehta, and I also appreciate her team for this wonderful concept, and I also appreciate Dr. Sundaram, Inamdar sir, all the dignitaries on the dais. And I'm sure that this particular conference, along with our partners, is going to be a great contribution to the field, a fundamental contribution to the field. And it's not that we organize only one conference and that will be the end of this particular endeavor, but we expect to continue this particular purpose of joint effort, this particular purpose with joint effort. And I'm sure that the industry is going to help us in this. I thank Ultratech for supporting us like anything, and so many other sponsors, other collaborators. So let me formally appreciate VASCON and the VASCON officials. I just received them at the entrance. And ESA, our own organization. Then the Ferrocement Society as well. And as you all know that this particular technology has a great future, and I was being told by Dr. Milind Kulkarni, कुठे बसलेत? हां, इतके मागे? अरे बरं, ठीक आहे. So he just told me the importance of this particular topic and India's leadership in the world. Am I right? In this particular field. So it was a great information. Thank you, sir, for this. So we would like to start a department in our college for ferrocement technology. And I request Ultratech for a long-term association and a continued effort throughout the year. Not that one conference is over and that's the end of the function. It's not a function, but we want we want to establish a lab. And I'm told that Ultratech is glad to give us support in establishing a lab for this topic and in general in construction technology. So I thank Ultratech for the same. With this, I wish all the participants, and I promise that all the participants are going to be immensely benefited in next 2 days. Even the site visits are also very good. And I thank all the contributors who have helped us in organizing the site visits. I formally thank Council of Architecture for always standing behind us, always supporting us, and in particular, our President, Council of Architecture, Abhay Purohit sir, as a constant support. Whatever we think, he is always ahead, and he said, okay, you go ahead, Council is always with you. So in future also, we shall expect the same kind of support. Actually, I don't have the names of all the professors, but my professor will understand that I sincerely appreciate their efforts. Initiative was taken by Dr. Sujata Mehta and Ultratech. So I appreciate their initiative as well. And I'm sure that next 3 days, it's going to be a wonderful treat in technology and construction, and of course, Ferrocement in particular. And at the end of 3 days, I'm sure that students will be immensely benefited. I would like all the students to be a part of this and try to gain as much knowledge academically, because one more very important point is architecture college is not just about, or any college for that matter, is not just between the first word of the syllabus and the last word of the syllabus, and only examinations and viva and sessional. But the real knowledge is understanding the success stories in the field, and the success stories like Ultratech and all the successful personalities here, they are going to share with you their knowledge, and that is going to be the real education, and not only the syllabus. So please look at this particular conference from that perspective, and please attend 100%, and please take notes. And I'm sure that the great personalities who are present here, they are going to give you exceptional knowledge, and you will thank me later on. So dear students, I also appreciate you are here and you are attending this conference. So with these words, I take your leave, and I wish every success to this conference. Thank you.
Thank you, sir. I request Dr. Anurag Kashyap, sir, to felicitate Professor Architect Abhay Purohit, sir.
This particular memento is not just any other memento, but it is a wonderful creation by our students, by Bnca, by professors. The first parametricism reflected in the construction, the first parametric design of India, and we have actually constructed this at the beginning of Curve Road. So whenever you are passing by Curve Road, please look at this particular structure as the first example of parametricism. Thank you.
Thank you, sir. Now I request Professor Architect Abhay Purohit, sir, to felicitate two of the speakers from today's post-lunch session. Mr. Abu Sadiq, sir, is here from Bangladesh. Sir, please. We will be having the keynote session by Mr. Abu Sadiq in the second half. I request Mr. Owen to please come on the dais. Abhay Purohit sir, kindly felicitate Owen sir. Yes. It's my privilege to introduce Chief Guest Professor Abhay Purohit, President, Council of Architecture, India, with over 3 decades the experience in architecture and education policy making and sustainable urban development, with a strong focus on raising educational and professional standards in the field of architecture. He is the visionary leader known for advancing professional standards and sustainable designs in India. Sir, we are honored to have you here. I request you to share your few words and address the audience, please.
Dr. Anurag Kashyap, all the dignitaries on the dais, experts who have come from other countries, experts from India, architects, teachers, students. I'm happy to be a part of this function. And there are indeed the reasons for it. In fact, I began my professional journey as an architect from Auroville. And at that point of time, Auroville actually was a hub of a lot of experimentation, and Ferrocement was an integral part of it. Over these years, and that we know in architecture we have something like about 50 and odd various disciplines which are sort of combined together, and maybe people are exploring a lot of areas, and sometimes the areas of their own interest. And somewhere actually I felt that certain technologies which had a tremendous scope to be experimented with, to be explored, remains to be in the certain very confined domains. And I felt that the due which was supposed to be there for Ferrocement actually is not really there. And this is because I'm talking about, like, I just got exposed to Ferrocement maybe about 35 years back. Now in these 35 years, if that was an introduction point or somewhere there prior to that, maybe, and then what kind of the experimentation which has been sort of done, and how is that material being projected? Because we know that there are the obvious sort of the advantages by using such kind of a technology, whereupon you keep on saving on the material, you keep on saving in terms of actually the sort of the volume, you keep on saving in terms of the steel, you keep on, the list is actually quite big. But at the same point of time, yesterday I was discussing with someone and I said that, like, okay, but Ferrocement, maybe how much has been used and explored and exploited by architects may remain to be a question. But actually I see those people who are sitting on the roadside, those who are capable of making those tree planters, and there are these experts which has been created who would come and who would actually create very thin partitions in the cupboards. In fact, the team from, I don't know, somebody from Telangana, whether somebody is here, but in Telangana actually this has become a very, sort of a localized sort of a technology, whereupon you have the local artisans who are capable of actually using Ferrocement in a fantastic fashion. Our problem primarily is about openly sharing our thought processes. And I'm not talking only about the Ferrocement per se. when I look at that, I realize that you talk about any technology for that matter, as such, we are a bit secretive. And so when some kind of a research starts happening around as such, I start doing it, and it actually I'm capable of climbing to that. And the another person would come and he would again start from the ground. And the third person, and the fourth person. But if I would have built on the experience of another person as such, climbing the heights would have been quite easy. So I keep on wondering that so many materials, so many technologies coming in picture as such, how many institutions across India or maybe across world for that matter, architectural institutions, maybe engineering institutions, and so on and so forth, they are really seriously looking at ferrocement as one of those actually materials which needs to be technology, which needs to be really to be explored and to be found out as to in today's context what relevance it is having, and are we capable of adopting it in a more effective fashion. And towards that, Dr. Anurag Kashyap said that he would like to have a department of ferrocement here, and I welcome that idea because I too, at a council, we are having a center of excellence being established at Bangalore, whereupon we intend to put up about 25 state-of-art laboratories, a sort of a platform whereupon the experimentation and also dissemination of a knowledge in built environment, not only about specifically for architecture, and it is not only specifically for Indian architects or Indian technocrats per se. The platform essentially is meant for the entire world, whereupon people could come, people could gather together, discuss, find out, look at the publication, look at the research, and then collaborate. And thereby we are capable. But then essentially I always thought about it as a sort of a very sort of a open platform. I don't think that making the patents would be the aim of that, possibly. It's not a captive technology which has to be kept there, but the experimentation should be for the use of all. And there, on one side I'm talking about the bamboo, on the other side we are talking about AI, and also we will be talking about the ferrocement. I look at it as one of those rarest of the rare opportunities whereupon we are talking about today. We are at the explosion of the technology. It's a different sort of a world order which we are trying to create in the technology. It's inevitable, of course, and we have seen when the computers came into existence, this is what has happened. Those who were in the part of a technology as such, they prevailed. Others have to silently move out. And when we today talk about the AI and we talk about the disruptive technologies which are the part and parcel of it, and on other side as such, we are also essentially focusing our attention, not as an option, but as a compulsion to the sustainability, sustainable development goals. Specifically when we talk about a country like India, whereupon which is going to rise to all those, I'm not worried about the number game, but those actually 4-5 top economies, and India certainly is going to be there, and we are going to see an explosion of actually construction activity in a big way. The estimates are suggesting that whatever infrastructure which we have today, in another 30 years as such, it would be at least 5 times more. And that's a big leap. But while doing this, there also is a responsibility, a greater responsibility, because the developed world actually had seen, experimented as such, and found out that now there is no other way but to have the sustainable scenarios. And development, whatever is going to happen in India, actually would have that kind of a responsibility which has to be taken up. And in that larger context, ferrocement is one of such materials actually which could be again sort of looked at in a bit different fashion. And I would explain. When ferrocement movement started, at that point of time, there was a consideration. Of course, the reduction of the scenarios was one thing, getting the thinner part of it is another thing. Flexibility to work, the forms which would be coming in. And another major aspect was that like the technology could be sort of put up at a local level, whereupon the local artisans and the local people also could get involved and start working on that. And we have seen that happening around across. Our components of the buildings, our cost-effective residences, what they call as a low cost, but I don't know whether that is a proper word. It has to be a cost-effective. Mass housing, how Ferrocement is capable of adapting itself to or serving the purpose. And on which research has not been done, but then, I was thinking about it and I realized another thing as such, that we are integrating everything with the technology as such. And when we are talking about a 3D printing, we are talking about integrating that as such. It also would be very, very interesting to see, and some research has to be really to be carried out, whereupon you are actually capable of integrating the 3D technology with that of a ferrocement technology. Seems to be a bit difficult, but it is not really difficult, because then you are talking about the layering of the, meshes, and so what would happen to the material and all that. But the forms could be actually properly well conceived. And there is a possibility of carrying out the techno-analysis of the scenario. We would require certain things which are capable of, it's not only about question of the craftsmanship anymore, it's actually validating whatever is happening around as such. And if that validation happens, ferrocement could get its due importance, which in my opinion, presently we are lacking it a bit. Because the practice is happening as a sort of a fancy practice, which actually is not a right way of carrying out the ferrocement practice. I don't know whether there must be structural engineers out here. They also would be discussing about it as such, as to whether the proper analysis of the scenario happens, whether we are capable of convincing it, looking at it in a proper fashion, whether it has been looked at critically, or is it a job of an artist, an artisan, by which we are looking at it. So are we getting fantasized, we are getting just overwhelmed with the material, or is it actually going to be used for the common man, for the common people, whereupon architecture actually is a public art? Immense possibilities are there. As to whether in the today's definition of a green we are capable of putting up ferrocement, and I believe that yes, there are the possibilities. Are there the specifications which are drafted as such and has been accepted by the government agencies is another part of it. These are all the areas which need to be explored upon. And is it becoming an integral part of us teaching to the future generation of architects is also another vital question. To this extent, Council always and is looking forward to actually document, publish newer technologies or the technologies, etc., etc. And I'm not very sure as to on a ferrocement whether we have a concise book available. If it is available as such, whether we have the Indian examples into that also need to be seen. If that is there as such, to what audience is it addressing, that also has to be seen. And if it is capable of addressing the students as such, then make council partner to it as such, and I promise you that I would just take it over and put it up across. Please develop the ecosystem whereupon we have the trainers available, and we can create actually the master trainers in the schools of architecture, so that it is ensured that at every local school level there would be some kind of a experimentation, some kind of a dissemination of knowledge would happen. If we take that responsibility, and I'm not talking about only schools of architecture per se, I'm talking about whoever is, whatever is a profession which is dealing with the built environment, it could be the civil engineers and civil engineering institutions across India possibly, we can take it up in case if required as such. I also have a good relationship with some kind of a sort of a relationship of a mutual respect with AICT, and also it could be taken as a joint program, because soon I'm going to sign MOU with AICT also in another 7-8 days possibly. So the collaborations is a part of it as such, knowing from each other, understanding that what is the progress which has happened and are we capable of building it any further also could be seen. And in this as such, we can, so initially we can start with what is happening in India as such, possibly, and if that books are available, then somewhere again, I mean, I'm sorry to say that I have not come across that book, and it essentially, you are in a process of making one. Thank you very much. That's good. That's okay. That's good. And so that we can absolutely take it up as such, because I believe that it has to go off. I mean, these are the hands-on scenarios which would happen in a big way. This requires not only the sketches, possibly it actually requires as to how to do it. And if that is what we are capable of doing as such, we would achieve our purpose. We would be capable of disseminating the technology in the proper fashion as such. We would be capable of serving the humanity in a most proper fashion. I come back to the students now. This is as far as the ferrocement part is concerned. And I see them in a large number, and they're all the force which is going to construct tomorrow for us. Please understand that presently your learning is happening in a sort of a linear fashion. This entire system of education is about to change. Not because it is a Council of Architecture or AICT is going to change it. It's basically because, again, the entire perception is changing. You are in a golden era whereupon actually you would be witnessing those kind of the projects which have not been seen by us. And that you have to carry out with a great responsibility. You also would see the practices which are emerging, which are no more only the architectural practices per se. You would find out that there are multidisciplinary practices which would emerge. And please get geared up for that. Also that AI is also in just the developing stages as such presently, but it has a tremendous application, and whether you like it or not, it is going to stay there, and it actually is going to be partners with the human beings. If that is so as such, it is your responsibility to actually address those concerns. Keep on updating your knowledge every point of time, skill set also for that matter, and also the collaborations which are needed across need to be actually found out and to be respected. But you essentially have a very, very bright future. Another 30, 35 years, 40 years actually is going to be that time whereupon you are going to demonstrate. And so be excited about it. But do it with the integrity. Do not compromise on the professional standards ever. Please do not do that. Because the moment you compromise on the professional standards as such, it is actually the path goes downwards. And that should not happen. You are lucky to be in a very, very good institution. It has been put up that so many number of international collaborations and the laboratories and the equipment and the technology and the teachers and the enthusiasm is all worth appreciation. So enjoy being student, celebrate being an architect, serve the society in the fantastic fashion. My best wishes to one and all. Jai Hind.
Thank you, sir, for your inspiring address. Now we are proud to unveil the cover page of upcoming COA Bnca publication that highlights groundbreaking work in the field of architecture and ferrocement innovations. For the same, I request co-convener Kanchan Atnurkar on stage, Engineer Vivek Botre sir, Engineer Vipul from Ultratech, Girish Sangle sir from Ferrocement Society, Rajiv Raje sir from ESA. Request you to please come on dais to unveil the cover page of the publication. सुजाता मॅममध्ये. हो चलो 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 पटकन थांब फोटो फोटो होऊ दे. Thank you everyone. We have few felicitations. I request Architect Abhay Purohit sir to felicitate two of the speakers of this conference, Engineer Milind Kulkarni sir and Engineer Ulhas Paranspe sir. Engineer Milind Kulkarni sir. Engineer Ulhas Paranspe sir. Behind every successful event stands a dedicated team of working tirelessly organizers. So I request Abhay Purohit sir to felicitate the core team of organizers, Dr. Kalyan Sundaram sir. Engineer P.P. Lele sir. Engineer P.P. Lele sir, President Ferrocement Society India. Engineer Girish Sangle sir. Dr. Sujata Mehta, co-convener. Okay, entire Bnca core team. Dr. Sujata Mehta, co-convener. Kanchan Atnurkar, co-convener. Professor Swapnil Shinde. And we also thank Professor Mahesh Bangad sir. He will be joining us tomorrow. He is also part of organizing team. I request everyone to take their seats in audience. We will start with the first session in few minutes. Just give us 2 minutes. We are setting up. The first session is online. Um, Professor Libretto is joining us from Italy. बाहेर घ्या. Joining us online from Italy, we are honored to introduce Dr. Libretto Ferrara, Professor of Structural Analysis and Design. Dr. Libretto is a civil engineering faculty at Politecnico di Milano, Italy. His expertise lies in advanced fiber-reinforced concrete, self-healing material ferrocement, with a focus on sustainable and resilient infrastructure. Over to you, sir. You may share the screen and switch on your mic. Sir, you are not audible yet. Sir, can you check
can
the
hear
audio
it.
ones? Yes.
You can hear and see me?
Yes, yes, sir, absolutely. We are just projecting your presentation. Please give us a minute. Yes, sir, you may please start your presentation.
Okay.
Thank you.
Thank you. Thank you very much, and a very good morning, everybody, and thank you to the organizers for having given me this opportunity. It's also a pleasure because this invitation came also through a former alumnus of Politecnico di Milano, and it's very nice to see how this relation between our university and students and India go ahead. Well, I like to start with this picture in which we compare, two concrete structures, two domes. One is the Pantheon Dome, built 2,000 years ago and still standing. And the other one is the New Orleans Superdome, where you can see we have gone farther in the span of the dome. And as a matter of fact, there is a change in technology. We went from unreinforced concrete to reinforced concrete. But I will say, how do we imagine our future? Which are the possibilities that we have with our construction materials? What is the scenario in which we have to build? And which are the sustainable development goals that we have to achieve also, we have to obey, we have to respect with our activity? Well, as a matter of fact, the challenges that we face are several. So we face aging infrastructures which need frequent repair, and the disruption of the traffic can be evident. We face the need for more powerful transportation infrastructures for people and freight. We face the need to manage the conservation of cities and also the transportation needs. And well, this connection need, you can see here, this is the network of the roads in the Roman Empire in the 2nd century of the Christian era. So this connection need for construction materials was always there. But nowadays we face the need of climate change. See, these are extreme meteorological events which pose threats to the people and to the structures. And so in this scenario, concrete and cement-based materials play an important, fundamental role because we consume every year 10 billion tons of concrete, which means about 4 to 5 billion tons of cement. But still, this is the biggest challenge because actually concrete is still the most sustainable choice. So what do we need to learn to do? Well, we need, for example, to promote the use of concrete in sustainable, renewable energy harvesting structures, because this is an important thing for the wind towers. Concrete, if we have to go higher, can become an excellent opportunity. You can see some examples here of how we can go using ultra-high performance concrete or materials which inspire themselves to the concept of ferrocement. How can we go from thicker to very thinner and slender structures with a great saving of material? So we have to learn to use a clinker with lower CO2 footprint, to use a cement with less clinker, to use concrete with less cement, to use less concrete, and to reuse. And also we need to develop the culture of repairing structures in a durable and sustainable way. Because as a matter of fact, as you can see from the numbers here, 50% of repaired concrete structures failed once again, and 25% of them in the first 5 years. So this is an important message that we have to deliver. So we need to learn also to think our construction materials not only in terms of strength, compressive strength, and kilos of cement per cubic meter, but we need to learn to consider the material in terms, for example, of efficiency of the binder component. We can see here that the higher we go with the strength, the better becomes the use of the material in terms of strength. And we need to learn that our climate change can pose threats to our structures, for example, increased attack of carbonation, chloride-induced corrosion, and so on. So I want just to bring you a very brief overview on the results of a project that we worked in Europe in the past years with a large consortium of partners with funding from European Union. I had the privilege to coordinate throughout this consortium, which encompasses the whole value chain of the concrete construction industry, and we worked on product, process, and context level. So we started from UHPC materials, ultra-highly durable concrete, and we wanted to scale this concept not only to the compressive strength, but we wanted, and this is the lesson that we also learned from ferrocement, this material which in tension is able to withstand not only high stress levels, but also to deform up to considerable levels. You can see here 0.5%, which is far beyond the yielding strain of conventional steel. We also valued the possibility that this material can self-fill the cracks because of continued hydration and calcium carbonate formation. You can see here some images of cracks which really close up in different exposure conditions. You can see here the growth of the self-healing products where the self-healing occurs, and here where there is no self-healing, images on the microscope, which are quite interesting, and other images of the results that we obtained in our research. Also, for example, delaying, these are classical images for chloride penetration. You see before healing, the area penetrated by the chloride was pretty large, whereas it was fairly much reduced because of the crack seal. So we worked on a round-robin test in order to see whether these results were repeatable, and you can see that with 7 different laboratories, we had a good repeatability of our results. We developed a database in which we collected more than 100 data, and we elaborated them also with the help of artificial intelligence, neural network. We developed a crack closure kinetics index, which depends obviously on the initial crack width and on the exposure type, and developed also design charts in which, for example, we correlated the capacity of healing to crack width and to the period of healing. We validated the capacity of the material to keep the mechanical performance also because of micromechanical interactions between the fibers and the matrix. You can see here all these healing products deposited. And also what we observed, you see, this was a very thin section, very typical of this application, ferrocement or UHPC. And we have a healed crack here. And when we reloaded our material, this crack stayed closer, means that it was really strong. And this crack reopened a new formation of fresh cracks. So we scaled up. This was a real job site. We scaled up to real volume, real casting volumes. And I want to show you some pilot examples that we built using this material. This is a basin. And here on the top left, you have the conventional reinforced concrete solution, which is 10 centimeters thick. But with our materials in precast slabs, we were able to go to, you see here, 3 centimeters thick. So very thin structures for this kind of application, and examples of the load test and with the grit saving of material, because for square meter of tank wall, we went to 35, from 35 to 80 kilos of cement, so grit savings. Obviously, you need to develop reliable structural analysis, structural design. For the slabs, we designed with the yield line methodology. These materials require some nonlinear design, but it's okay. And also we validated this concept with real full-scale tests, and we were able to save in the real structure, to save great amount of material. But what is more important, I want just quickly to show this. We also were able to prove that up to 1 year exposure, there was no change in the material performance, that the corrosion, this water was very, very high in chlorides. The corrosion was really limited to the surface of the fibers, and the material remained integer. So we were able to go down from, in 50 years of service life, from 10 to 16 maintenance to just 1 maintenance operation in 50 years, with great savings in costs and with great savings in impacts, which is absolutely what we are requiring from our material. We also proved that this material can be recycled with no detriment to the performance. You see, compare the yellow, which is the reference, the other solutions, which are with different recycling percentages. We proved that we can reduce the content of cement, because when you crush this material, there is quite some fine that you can reuse as a replacement of cement. You keep the self-healing capacity, and also we validated use of this material in, for example, post-fire curing. It was exposed to 200 degrees, and then it was recured, and you can see here that it recovered the flexural stress capacity and also the capacity to close the cracks. As you can see from these images, this is the reference material. This is the material exposed to 200 degrees, and this is material exposed up to 400 degrees. And you can see that the cracks were closer. We also proved this in freeze and thaw materials. We proved this material under impact. You can see this very thin slab, just a few centimeters thick. There was a recovery of the natural frequency, and other pilot structures that were built by the consortium of the partners. This is a raft for mussel farming. These were pre-stressed UHPC beams, very thin cross-section. This was a floater for a wind tower with walls with just a few centimeters thick. So really very interesting application, and you can see also some other pictures. This floater follow obviously, and you can go and inspect it. There are pilots which are really installed in the real environment and tested. This is a pontoon in a harbor in Ireland, and this is an interesting retrofitting example in which we use a different kind of composites use a UHPC in the columns, you use a TRC, like a ferrocement. This was with basalt meshes in the retrofitting of the drum. You can see the amazing result that we obtained and some images of the job site and images of the cracks which were. Now with my research group, we are also going into embedding self-sensing capacity in these thin composites, which will bring them to a new frontier and these other. So actually also a brief job of dissemination, public engagement. This is an event, Brussels, in which we try to approach people. This is a conference that we organized in Milan with major stakeholders and some images of the consortium meetings for these projects into, this is a collective achievement of all the partners, and I really want to thank them for all the results that we have achieved, and to also thank the students that worked with our group throughout this year, contributing to achieve these results, and my PhD students and the funding agencies. And also want to invite you next June, you see here the dates. This is a preliminary logo. We will organize the 15th International Conference on Ferrocement in Milano, Ferro 15. The last event was in New Brunswick in 2024, June last year. Then it was in France before, and it was in 2018 in Belo Horizonte in Brazil. Always very nice to see all the community and all the people there. And I really thank you for your attention.
Thank you, sir, for your insightful and very informative presentation with versatile use of ferrocement construction. We will take a pause and we will take few questions from audience. We have the people who have joined online as well, so I request them to put your questions in chat box so that we can discuss that. Any questions from the audience? Yeah, we have one question. Swapnil sir.
Good morning, Professor. So my question is with respect to the floating rafter or the floaters. Let's say these UHPC or UHDC floaters are installed in the water, and what if over the period or in service condition there are cracks or some leakages? So how these can be rectified?
Yeah, thank you for the question, because it helps me to point out, some some issues. I will just reshare the screen.
Yeah.
You see, can you see this slide?
Yeah.
Okay. Well, as a matter of fact, this was a test setup that we developed. You see here, these were very thin beams, which were pre-cracked, and then were immersed into salt water in the pre-cracked state and kept under this state, so there was kept the deformation constant and so on. So up to 1 year, if you see this gray one is the envelope of the test at time 0, let's say, and the colored curves are the tests performed after 3, 6, 9 months, up to 1 year. So the material did not exhibit any degradation. And also, if you look at these pictures here, these cracks are at the surface, so you can see that there is some rust. But if you go inside, there was no corrosion. So as a matter of fact, and you can see here some images that I showed you. So for example, this one here, we had cracks, but they were completely closed. Some images are here.
Yeah.
So actually, because the material has this self-healing capacity, the cracks can form, but the cracks heal, and there is no significant degradation of the material performance. We observed this in the lab up to 1 year, and we are observing this in the field. All these pilot structures, I have to say, they are in operation for about 4.5 years, because they were all built in the late 2020, early 2021. So it's now about 5 years, and it's a very, unique opportunity to really monitor them on the real conditions. And as a matter of fact, this is the advantage of UHPC, of ferrocement, because of the very tiny distributed cracks. You not have significant degradation because the cracks.
I'll just put it in this way. Let's say
I hope that I have clarified your
yes, yes. It is means clear, but still I have another question. So let's say means when the structure is in operation, for example, this on the top of the floater there is a wind turbine, let's say floating wind turbine or any other structure, and it has the self-healing capacity. But on one side, because of these minor cracks may lead to the ingression of the water, wherein the stability of the structure would be compromised. Means do you have any view on that? Because we have a real time means challenge in one of the project. There the ingression of the water creates a problem.
So can you repeat, please, because I missed part of the question.
So for example, on these kind of floaters, wherein the wind turbine or any other structure is installed, and these are compartmentalized. For example, there is a crack over there, and then that leads to the ingression of the water. So once the water ingresses, automatically the buoyancy is lost. Now the self
What is lost, pardon?
the
What is lost?
buoyancy of the structure or the floater. So I'm talking about when these are floating in condition.
Yeah.
Yeah. So
Oh, the buoyancy, you mean?
yeah.
Okay.
So when the water ingresses, automatically the structure weight goes up, and you can say in turn the buoyancy losses. So the stability or the hydrostatic stability compromises. So means
Well, yeah, I would say that, we did not observe this in our pilot. One has to
okay.
go from case to case, yeah.
Okay.
But if you look at the case, probably I'm just thinking loud voice. One can design so that the structure keeps the buoyancy up to a certain crack level, and at the same time allow the structure to manage this, or going for having a cracked state with very tiny cracks where the water, because of capillary, cannot ingress because the crack is too small. This could be a choice, but actually, really, I cannot answer because it's a very particular case, and one should really go into the numbers. But the strategies could be those ones that I just tried to devise. Yeah.
Sure. Thank you so much. Maybe I'll connect with you at a later stage.
Yeah, sure. You will be welcome.
I have a real time problem, so maybe we
I
can
will,
connect.
We'll be happy to go deeper with you in this specific case. Yeah.
Sure. Thank you.
Thank you, sir. Any more questions? Okay. Thank you so much, sir, for taking out time and guiding the audience. We will now proceed with the next session. Thank you so much.
Thank you very much. Thank you very much. Very happy to join you.
Yeah, same here. Now we are moving ahead with the next session. We are happy to have Engineer Vivek Bothre sir, Director of Projects, Vascon Engineers, today. Vascon Engineers Limited is one of the leading Indian construction engineering company with over 30 plus years of experience. We are happy to have a support from industry for this conference. I request sir to come on the stage and start the presentation.
Good morning. Good morning, ladies and gentlemen. Actually, this is not, we are not related to Ferrocement, but willingly we want to associate with Ferrocement. That's why we had sponsored this event, and we are joining with the Bnca college regarding this subject. Vascon Engineers is leading construction company in last 4 decades. Mostly, I will give the small introduction about the organization of the Vascon. Before 39 years, Mr. R. Vasudevan has founded this organization, and this is the purely engineering company. Vascon Engineer in this industry, they are working in real estate as well as hospitals, metro sheds, airports, hospitals, and various EPC projects. And our company is always maintaining high quality standard, innovation, and high quality, high level safety standard. It is very special for us that we are working in construction and architectural industry, actually which is playing the true source of the successful growth of prosperity. In this 39-year journey, last 5 years, we are the fastest growing construction company in India, and we had awarded fastest growing construction company in the construction sector. Allowing this conference, nowadays there is a significant shortfall of the manpower, and this industry require the innovation. So we have so there is no option to adopt innovative policies, mechanism, and whatever we are means ki minimum labor manpower involved in the some structure kind of. To complete the construction activities in day-to-day manner. Aligned with this innovation, Ferrocement Society is playing important role. The Ferrocement Society, what I heard, is taking efforts to introduce new products, materials and new technology to their segment, and it will help to make construction more efficient. Actually, I had attached and I had taken initiative because I had done one project in Ferrocrete in my college days with help of Dr. Bnca. They had suggested us to do one project, and we had done before 20-25 years ago. He had taken so much efforts to promote the ferrocrete industry and ferrocrete technology. Nowadays, in Ferrocement Association, his son, Mr. Pushyamitra Divekar, also taking efforts to promote the ferrocrete technology through Ferrocement Society. FASCON always promote the new innovation. So we would like to connect the Ferrocement Society in future for our upcoming projects. FASCON also aligned to this Ferrocement Association. FASCON also started some innovative part, and we required the help of Ferrocement Association Society in our future innovation. Sir, we are doing composite structure with help of post-tensioning. We have started this research and development in last 2 years. We are starting this innovation for the commercial IT buildings, hospital buildings. This innovation we have started with our sister companies. We have a sister companies. FASCON is the EPC company. They have design company. They have a post-tensioning company. Fastech Consultant is our designing sister company. And this innovation of composite structure with help of post-tensioning, we are introducing through our Stress Tech Engineers Limited, who is doing rock anchoring, piling and post-tensioning in the construction industry. We will show our company's vision, our project, what we are doing in current, what we had done in last, and what is our future vision through the presentation. For us today is very special day as we got the opportunity to make our company more recognized and share our vision through this platform. We are very thankful to organization committee, Bnca College Management and Ferrocement Society for giving this opportunity to us. Thank you. Jai Hind.
Good morning all. I'm Mukul Balla. I'm part of Vascon Engineers. We had prepared a detailed presentation. Bhutres Saab spoke most of it. Fir bhi I'll just run through the entire thing, which will show basically what kind of work we have been doing and how beneficial we would be by associating with Ferrocement and vice versa. See, we have been trying very innovative structures since quite some time, and there is huge possibility of doing this innovative things in our organization and with our clients also. I'll quickly run you through to some of the structures what we have made and what we intend to do in near future. Vascon Engineers was conceptualized and it started its operations almost 40 years back. Vasudevan Saab, who's our founder director and is currently a chairman emeritus, he started this company in 1986. A visionary person who has worked all across the country, given some immense, has some immense energy. Though he's pretty, taken a backseat nowadays, but still very active in advising everything in our company. Mr. Siddhar Vasudevan, he is the managing director, son of Mr. Vasudevan. Santosh Sundarajan Sahab, he is basically the CEO of the company, he is the group CEO, he is a civil engineer and he is also a doctorate, a PhD in structures. So people can understand what is ferrocement, for us also, as in terms of innovative ideas to be implemented. As I said, we have a legacy of almost 4 decades, built almost 50 million square feet of projects all across India, 200 plus projects, 39 years of experience, and presence across the country, almost plus 30 cities. Again, the same thing. Third point which I want to emphasize, in-house design for RCC and pre-stressed and post-tensioning structures. As Botra Sahab already mentioned, we have got a extended arm as Stress Tech and Vastec. These are 2 companies with us who are actually working in post-tensioning and execution work all across. We have, though being a 40-year-old company, we have tremendous amount of, building capacity. We have an annual building capacity of 8 million square feet. Currently, we are doing around 4. We have a huge scope of extending our work, all integrated with SAP and ERP methods, which is latest going on. We are a EPC company. Apart from that, we are into real estate also. In fact, a lot of skylines in Pune, we have designed and changed the areas. If people know, Kalyani Nagar, Marigold is one of the projects which have changed Kalyani Nagar skylines. Similarly, Wakefield IT Park, which is in Viman Nagar, built around 15 years back, that changed the skylines of Viman Nagar completely. So, some of our projects, I'll just go in details. These are some of the EPC projects what we have done. See, this is one of the award-winning project what we have recently completed. This is Raj Bhavan at Raipur, Chhattisgarh. Recently completed, we have won various awards and process. I'll show you certain videos also if I have time permits. One of the most recognized project in that part of country. This is Adampur Airport, what we finished in a record time. I mean, in Operation Sindoor, people must have seen this airport. Though it's a defense airport, not allowed for normal public, but most of our defense systems are placed here. I mean, we built in this project on a record time, and we got an appreciation from the Ministry of Defense also for this project. This is the medical college what we have built in Chennai. Again, Dayanand Medical College. Now, if people are aware or not, the Suzlon headquarters in Pune, that was done by us. Though it's a almost 12, 13 years old company, construction. But this was something which we did in 2012. First IGBC LEED certified building in India. 8.5 lakh square feet, still holds good. This is what I was talking of. These buildings, the Wakefield IT Park, these basically change the skylines of Viman Nagar. This is the Symbiosis College, what we did. We have done the multi-level car parking way back in 2010 in Delhi. This is right outside the airport. A lot of people who have moved around Bombay, they must have seen this building. This is Ruby Mills, one of the tallest tower when it was done in Mumbai, roughly 119 meter tall. Sadhu Vaswani Mission Main Institute, what we have done in 2018. And these are some of the unique buildings and some of the work what we are doing currently right now. This is a very prestigious hospital being done in Bihar, a 30-bedded hospital. 600 crore plus is the value of this project. Huge magnanimity of this project is huge. I mean, if you see this, this is a challenging project what we are doing. Basically, this was a pond which we have filled up, and we are doing entire construction in a pond. Imagine 20-25 pumps, 40 to 50 horsepower working all through the day to give you a clear land to work. I mean, immense amount of engineering is being carried out in this particular site. This is a Capgemini project, the corporate office in Chennai, what we are doing. This is a SketchUp image in process. The curtains are to be unveiled. We'll wait for some time on this particular project. Again, a 500 crore plus project. This is a Dabolim International Airport. This is also we are doing in Goa. These are currently at the final stages. Just completion stage. These are actual pictures. This is a hospital project in Bijnor. Another one, this is in Kaushambi. And this is what we are building in Kodarma, Jharkhand. So the government is, too much concerned about the health facilities to be given across. This is again a project, 750 bedded Pimpri Chinchwad mein, what Mr. Botre Saab is only handling. It's a huge project. Again, we are doing some work in Sindhudurg, again a hospital. We are not specialists in hospital, but somehow you've got so much of hospital work that we become a, people call them Vascon, to hospital banane wali company hai kya? So, I mean, these are all ongoing projects which are there. And still, I mean, 2-3 projects are again in pipeline, which are again in hospital, not our fault. This is a beautiful building we have just, it's the verge of completion. This is a police housing work in Mumbai. Right heart of the city, as in Bulund, almost 12 lakh square feet of area and 37 story high. I mean, in dense area we have done this work. Images are almost the same. This is, though it's a rendered image, but it's almost the same. We are doing some work for Vedanta at Barmer, the residential project. We also do jail. Huh? So this is Amethi jail, what we are doing. Jail, it's jail. We call it a jail. Jail, Karagraha you want to call it. And then some of the real estate project, what I said, which is also a part of Vascon Engineers. This is a Windermere at Koregaon Park. If people have seen this high-rise, very premium, high-end projects what we have done. Again, when I was saying, we have changed skylines of certain areas, so I forgot about Kharadi. Forest County is one of the projects we again did way back in 2010-12, portion is still pending. This changed the skyline of Kharadi. I mean, before WTC and Eon IT Park, this was a project which was talked about. Again, a huge project, 15 lakh square feet roughly in that area in 2010-12 was something nobody would have imagined. Yes, some of the other projects what we have done in Pune, these are, Forest County, Forest Edge and Platinum Square again in Viman Nagar. This is a unique building, special architectural element which is there. This is again being done in Kharadi. It's halfway through. Though it's a small project, but you can see the elevation of this particular project. Architects will be very much interested in seeing how this is being executed. Again, we are doing some good residential work at Powai, Mumbai and Santa Cruz. These are still in progress. Powai's work is yet to start. And these are some of our marquee clients. We have dealing with most of the top notch players in India today. And we do private work also for developers also, and for the various companies, IBM, Cipla. As Botre Sir spoke of our extended arm, we have got an innovative wing also with us who support us in our day-to-day execution work. Vastec is one of it. Vastec is a structural designing company, again headed by our CEO. This company has done tremendous amount of work across country. They have done some unique buildings. You must, visit one of those, their websites and have a look. They are very innovative. The kind of people who are sitting out here will be, amazed to see the kind of exploration they are ready to do and they have been doing. So associating with you all and with the Ferrocement and all, plus they will also get to have some innovative ideas how to construct lean structures, lean thin buildings, and some innovative designs also. Just brief about Vastec. See, they're doing work on composite structures, composite steel structures also. This is also something coming up in a big way in the market today. A lot of companies are asking for these composite structures because of the speed. That's the most important thing out there. We also have an extended arm for execution of post-tensioning work and rock anchoring, etc. This is the Stress Tech. And they have got presence in most of the cities in India today. And these are the partners what we have worked with. That's all. Thank you. Thank you so much.
Thank you, Engineer Bhalla sir, for very informative presentation. We truly appreciate your valuable contribution and support from Vascon engineers for this conference. Now again, we will be having one online session, a keynote speaker joining us. So we will take a 2 minutes break to arrange the system. Gentlemen, we will be starting in 1 minute. Should I start it? So as we move forward, we have joining us online from United Kingdom, Engineer Pete Winslow, Director, Expedition Engineering and Useful Simple Limited. Let us welcome him virtually. He is already in the meeting. Engineer Pete Winslow. Welcome, sir. He is a chartered civil and structural engineer specialized in infrastructure innovations, carbon law solutions, and sustainable engineering. Sir, you may start by sharing your screen and start with your keynote address to the audience.
Thank you very much, and thank you so much for having me here today. And so actually today I'm going to be presenting jointly with one of my colleagues, Engineer David Hewlett, about the Stavros Niarchos Foundation Cultural Centre and the major Ferrocement canopy that we've had the fortune to work on and in fact then monitor for the last 9 or 10 years, which is quite a rare opportunity in consulting engineering, we felt. And so today we're going to say a bit about, I suppose, that sort of end-to-end work that we've been doing. Very much at the beginning, starting the design and conceptual work, thinking about a big canopy for this cultural centre in Greece, in Athens, all the way through the concept, design, testing, development phase, and then an ongoing sensing and monitoring work for the last 9 or 10 years. And so hopefully you found that interesting. And I think, so now I'm a director of expedition. Actually, at the time when we began this project, I began being involved in 2009. That was when I had just finished my PhD at Cambridge University, and then came in as the project engineer for the roof, working with the directors at the time and with Renzo Piano on the project. I'm actually going to hand over to my colleague David, introduce him, who will do a little bit of a double act because he's been absolutely instrumental in the project too. So David is a fabulous associate engineer in our team, structural engineer and civil engineer as well, graduate of Cambridge University. Now actually quite a few years into his career, having been leading the monitoring work for the last 10 years. And so, David, over to you, I think, to talk through a few introductory slides, and then I'll be going into more detail about the Ferrocement design and development work.
Great. Thank you very much, Pete. I'm hoping everyone can see my slides and hear me okay. Let me know if not. So just moving on to where we are. So we're in Athens, which hopefully you all know. It's capital of Greece, and then looking at the site within the city. So we're positioned near the coast with the red rectangle, and then the site is oriented on this axis, which points up towards the Acropolis, which is probably the most famous part of Athens itself. Then looking at the site, so we've got the main building, which is there, which hopefully you can see my pointer. It's next to this long reflecting pool, and the building is positioned within this fantastic park, which is open to the people of Athens. Then taking a long section through that building. So this here is taken from the sketch from Renzo Piano, starting from the right and then moving to the left. So you're walking up this hill. It's as if the landscape has been peeled up in a similar way to how the Acropolis stands up from Athens. So does this building. So you're walking up through this park, and then you've got the agora between those buildings. Around here, you've got a car park. You've got the National Library for Greece. Then you also have the National Opera, and that is topped by this canopy. So taking a short section through, so looking through that big opera house. So you can see at the very top is the canopy, which is the thing which is of most interest to us. And then that's sitting over this large building with some pretty long spans. So we're spanning about 75 meters at its maximum across the middle. It's sat on some quite soft, long supports there. And then the entire building is base isolated because, of course, Athens has a significant amount of seismicity. Then zooming in on the canopy itself. So here we've got a top and a bottom flange, which are made out of ferrocement. That ferrocement is doing several things at once. So it's acting globally as the top and bottom flanges of a beam, if you imagine it that way. It's acting locally to resist the forces both from Mksss and from the solar PV array, which is positioned on the roof. And then it's also acting to provide this weather-tight membrane on the top and the bottom, as well as, of course, achieving excellent architectural quality for this kind of monumental building. Then looking in plan, just to get the scale, so the entire canopy is about 100 meters by 100 meters. It's positioned on these 30 columns, and each of those columns has a sprung head on the top that we're going to talk about later. The cantilever at the edge is about 12.5 meters, of course, extending to about 18 at the corners. And then each of the columns that you see is a 15-meter spacing. So I'm going to hand over to Pete to talk a bit more about the element of the canopy now.
Thank you, David. So this is actually a sketch by Renzo Piano from back in about 2009, late 2009, possibly early 2010. And really, I suppose that's when I started being involved in the project. And at this time, there's an international design team in place with expert Greek architect and engineers as part of the local team. There's Renzo Piano, Expedition Engineering. There's Arab Acoustics were involved. There was a sort of a specialist theatre project, because of course, it will be designed around the opera house and the user experience. And so this actually was one of the very early sketches about, I suppose, the concept and an ambition for the canopy, for the big solar collector canopy, as we called it. The intention was to gather the energy from the sun, to provide a sort of a lookout and a viewpoint, potentially be the sort of counterpoint, the modern counterpoint to the Parthenon and the Acropolis up in central Athens, which is sort of, if you see the direction of the arrow, the views is just a few miles away. And and I think that this started to sort of evolve as to what's the design and what the project was trying to do with the canopy as a crowning piece on top of the National Opera House that was also being designed and built at the time. And so there's a major complex was very much real high quality design for the Opera House, the library, the park, and then in a sense the Ferrocement canopy, or what became the Ferrocement canopy. At this point it was an architectural concept. We didn't know whether it would be Ferrocement or steel or something else. The intent, that was the special icing on the cake, if that's I don't know if that's a UK term, but there's sort of the crown on top. But obviously the heart of the project underneath is the Opera House and the National Library. So all in design phase, and that site that David showed on the map was it had been an old horse racing ground many decades before. It was used in the 2004 Athens Olympics as a car park, but somewhat underused, and that part of Athens was very very lacking green space, which, if you've ever been to Athens and sort of the heat in summer, is really quite oppressive, and actually the sort of the green space in the park and being able to enjoy the views is actually a crucial part that started to weave into the concept. So next slide, please, David. But at the beginning, as I said, the classic kind of thinking was, well, space frame for a canopy, tubular steel, struts and bracing. Maybe that's the way, that's the way to go. That's sort of a classic engineering solution to a 100-meter by 100-meter canopy. Could be efficient, lightweight. And actually, we began a significant piece of design development work with Renzo Piano and his team, and with Cambridge University laboratories here, to develop a very novel space frame as a tensegrity space frame with these sort of unusual tension diagonals to create a filigree structure that could float over the Opera House. I think that what became apparent is that on the one hand, lots of engineering innovation embedded in this and work going to develop it, but it's I think it became increasingly apparent to the whole team actually, and that it didn't necessarily fit with the historic architecture of Athens. Now, a new project is not about just copying the architecture from the 2,000 or 3,000 years ago, but I think there was a real desire to try and reflect the sort of solidity and permanence of architecture in Greece, and so something that was very filigree and floaty, and lightweight and perhaps sort of transparent isn't necessarily the modern counterpoint to the ancient Greek architecture, and so then ideas started to change as to, well, what could we do instead? What is a sort of engineering architectural solution that would fit better? So next slide, please, David. I think what started to emerge as a key theme was around the desire for canopy and a sort of architecture which was a sort of solidity and a monolithic nature, rather like the hull of a boat, which you can see drawn in the section on the left-hand side here. No joints, very smooth, and in fact, this, I believe, it is a Ferrocement boat, I think, if I'm not mistaken.
It's actually it's Renzo's own boat, actually.
This is something in the 1980s that Renzo made with his team at Renzo Piano Building Workshop, and sailed around the Mediterranean and in the summers for many years. And so that started to be one of the inspirations for the sort of architectural and engineering approach to the big canopy, rather than what would probably be a more classic approach to say, well, we've made it out of steel, we'll make it tubular, and then put some cladding on, which is what a lot of projects, certainly in the UK, that's obviously a very common approach, is to tubular steel and put some cladding on to get the shape that you want at the end. But in a sense, perhaps not so honest, because when you see a Ferrocement boat, the skin you see is there's no separate cladding. The structure is the skin, is the surface. It's doing those multiple jobs. It's the waterproofing. It's the smooth hull flow lines, and it's doing the sort of structural work. So that became a kind of key underpinning concept, which you can see started to get us thinking about Ferrocement and the opportunities that could provide as an engineering material. Next slide, please. And so this was actually early photograph of the canopy after we built it. I mean, this is sort of jumping forward about 7 or 8 years. But if it starts to get that sense of the smooth skin, the monolithic solid architecture, but still with a sort of a contemporary modern architectural take. You know, this is not big Greek columns; it's slender columns. It has a sort of approach to floating above the opera house, but the canopy itself very, very smooth, sort of single skin, monocoque skin that's doing the structure work and the cladding and the sort of architectural finish all together. Next slide, please. But then sort of back to 2009, 2010 period, this is a picture of me, my younger self, and one of my colleagues at the time that was actually leading the upper house engineering team. And so this is us having a go at making some ferrocement. And so we did this work up in Manchester University with Paul Nedwell, a ferrocement specialist at Manchester. And this was almost, I suppose, probably one of the best parts of the whole project, actually, because it was a sense that, you know, yes, we were consulting engineers, yes, we were based in an international office, but to really get to grips with the material and work out what you could do with it, how to you know, turn it into a highly engineered material to make this 100-meter canopy. You know, we knew that we didn't want to start with computer models. We wanted to start with understanding the craft of it and how we could work with it, and what's it, let's say it's you know, positives were and what the challenges might be later on in how we might build things and construct things. So we had a go. 10 of us went to Manchester. Paul Nedwell very, very kindly hosted us, and we made some ferrocement. Our ferrocement was probably not the highest quality, but we then began up a learning curve. Next slide, please. I suppose this is jumping forward a little bit, as you know, as we had developed the design, and you can see obviously the wire meshes that go in there, which was a welded wire mesh, multiple layers. I think it was down to 1 millimeter diameter wires for the surface meshes, but in the middle we were looking at 6 mil bars, and we developed a ribbed skin structure, ribs of ferrocement to stiffen on the back. But then this kind of steel spider is a crucial connection to connect between those rib ferrocement skins and the steel braces that could keep those two major sort of skins, those shells, apart. And figuring out how to do that and developing that both, you know, computationally, analytically, as well as practically. How could it fit together? How could we transfer the loads and the bracing into a thin skin, you know, and avoiding the kind of stress concentrations? And so a very substantial amount of work went into figuring out how to do that. Because I think what we found in that process was, you know, it's very different to carrying out normal reinforced concrete or steel design work, you know, in Europe or the UK. You know, we couldn't just open a manual that said, here's how you do a connection between a steel brace and a ferrocement skin. You know, as all of you on the call will know, these things are, you know, there's a level of invention, there's a level of, you know, go back to first principles. There isn't a design guide from Institution of Civil Engineers or Institution of Structural Engineers or the Code Committee that tells you, you know, this is how you do a connection, these are the principles. And so we went back to first principles to develop that with actually working with a local contractor in Greece as well, to work with them on testing and trialing and developing the local skill base in these methods. Next slide, please. And this was one of the sort of earlier mock-ups that was carried out to start developing the approach to making the ferrocement. And we were very, very aware that in designing a major canopy, we needed to do the design and, you know, advanced seismic modeling and so on in parallel with developing the method of making it in a way that we could build in some industrialization. And so you see here on the left one of the workers with almost like an ejector nozzle to push the mortar into the meshes to get good penetration. This is actually a spray concrete piece of equipment with a concrete pump, mortar in it, and then a pipe. They just take the sort of air spray nozzle off the end and put on this sort of adapted end piece to be able to sort of force the mortar into the mesh. But that gave us the confidence we could start to create sort of a higher quality, more engineered material with the sort of the strength and stiffness characteristics that we might need to be able to cantilever the distances. Next slide, please. As the development process continued, again, we were doing work in Athens in parallel with computer modeling, analysis, developing the underpinnings of the calculation methods, drawing on a lot of the different research papers and model codes and so on that had been developed in early 2000s. This here is a big test piece at the National Technical University of Athens, part of a fairly substantial testing program. And what this is doing here is actually a biaxial crushing machine, if you like, applying load in sort of X direction and the Y direction onto a representative panel of one of those skins. Because to span the distances, to resist the loads that we knew the canopy would have in terms of seismic and wind and so on, there was a very substantial stresses in the skins. And so this here is really about validating and sort of cross-checking between physical results and the computer modeling. And so you can see it's a rib skin. Different panel thicknesses are tested. The skins themselves varied between 15 millimeters and 55. With various layers of meshes and small diameter bars, and obviously this test rig, those yellow jacks you can see, each with a hose connected, is a 100-ton bridge jack. So we were applying several hundred tons of load onto this 2.5 meter panel, and we started to build a reasonably significant sort of body of test data to build the confidence that this could have the sort of highly engineered performance that we needed. Next slide, please. And the testing phase culminated. Oh, which slide are we on, David?
Do you want to do the jump test?
We'll do this one. So this, actually, our colleague Bruce, we spoke to him yesterday. He was the technical director for the whole of the cultural centre, canopy, and the other parts, overseeing it. And he said, "Oh, you've got to show this video." I think will this play? Should we try?
No, this is just a snip from the video.
Okay, we've just got an image. So he said, "Oh, the most important test was this one. It wasn't the the big scientific tests and the 100-ton jacks loading a panel. It was me jumping on a panel, because I think what we found is that in trying to sort of bring Ferrocement to a sort of a major canopy and go through the development process, the hardest bit actually was the bringing the client and the rest of the team along with us. And I think that's maybe that's a testament to all the fantastic previous scientific papers and published information on the topic, that we could feel confident as engineers we would get the strength and get the quality and so on. But it is building the confidence in the client and the project management team that this material could do the job we needed it to do. And I suppose that's particularly because prior to that, there's a sort of sense in Greece, in Athens, certainly in the UK, that Ferrocement was interesting material, but certainly not mainstream, and something which was not clear it could be a high performance engineering material. And certainly when you're talking about something which is 15 or 20 millimeters thick as a skin, would it be robust? Would it could it cope with somebody jumping on it? What if when they're building it, they dropped a hammer on it? All those kind of questions came up. Well, yeah, okay, you do your calculations, but is this strong? Is this resilient? And so me jumping up and down on it, and then we took a video at the time and sent it to the client and said, look, it's very, very robust, extremely strong. That started to build the confidence of the team. The architectural team could say, yes, look, we're on a good development path here. Next slide, please. And so the development phase culminated in the production of a substantial prototype. So this here, I mean, if you think back to the slide David showed about the cross-section of the canopy, this is actually almost a portion of the canopy. We cut out from the 3D model a little portion of the canopy and then built it down at ground level. So this is 1-to-1 scale, and it's about 1/100th of the final canopy in plan area. So this thing's about 15 meters long, cantilevering 7.5, and it's about 6 meters wide. And the purpose here was less about the sort of scientific testing and more about developing the skill set and the confidence that this could be built by local contractors, local builders, that could go up the learning curve and result in a very, very high quality engineered structure. And get the finish underneath, because it was crucial, as we said before, to get that monolithic look like the hull of a boat and the solidity. Next slide, please. Of course, we did load test it. We didn't just say, well, it's a demonstrator. We said, well, let's see where we get to. Let's load it up to the design load, which is what you see here with, I think it's about 100 tons of bags of aggregate on there. In fact, at this point, it still wasn't breaking. It could see it deflecting a little bit, but there was no major signs of failure or cracking. And so they then got many, many other blocks of concrete, cantilevers from some tower cranes on site, and put them on top too, and it still wouldn't break. So I think this gave it immense confidence of the resilience of ferrocement as a sort of a mainstream structural material. And then I think the next slide was something that I did in Photoshop on the way home. Because as Bruce and I were flying home from Athens to London, we realised that the load we had just put on this prototype was actually the same or slightly more than the fully loaded weight of the aircraft we were on. And so that made just sort of put that in perspective a little bit. It's a very non-scientific but very sort of human moment that helped build the confidence of the team, helped us go, hang on, no, this is a very strong opportunity that we have a chance to make work with Ferrocement for a big structure. Next slide, please. And I probably get a briefly to mention this, but feel free to ask more in the Q&A on the next few slides. This here is actually the first building built on site for the cultural centre, and it was a temporary factory to make and precast ferrocement panel sections. It's absolutely crucial to build the whole opera house within the schedule and the time available, was to start making substantial parts of it on the ground in parallel with building the opera house. We couldn't wait till the opera house was finished and then try to build the canopy on top. We had to start in advance. And of course, because of the fine meshes in ferrocement, we can precast a big piece, leave meshes sticking out, and then when we lap them, the lap length's actually relatively short because the bars in the mesh are so fine. And so this became a sort of crucial underpinning of the construction strategy. Next slide, please. These are the panels starting to go together on top of a big scaffold at height. You can see the sort of browny grey zones are the splice zones, which were then mortared together in situ, but the rest had all been precast. So we're about 95% was precast, prefabricated at ground level in the temporary factory. Next slide, please.
Your final slide, Pete, and I think we're at time.
Brilliant. And so this then is the finished canopy, and you can see that architectural concept has been achieved and crowned on top with the mast, which is a special flexible mast to sort of indicate the direction of the wind. Although unfortunately that one wasn't in ferrocement, we had to go and use a boat mast out of carbon fibre. But I think the ferrocement sort of speaks for itself, really. So over to you, David.
I'll be really quick just to avoid eating into the Q&A time. So I was saying that canopy is supported on 30 columns, and each of those is sprung. The reason being you have this canopy and the building is moving below it, either because of, say, something like seismic or because of creep of those longer span structures. And then also that the canopy itself, that top skin is heating up as compared to the bottom skin. So the entire thing is tending to bow out of shape during the day and then bow back during the night. So one of the key things that we looked at during our monitoring project was the movement of the canopy before the PV panels were installed. This is a graph taken from 2015. So you can broadly see the temperature, which is in green. So we've got some hot days of the temperature changing, and then we've got the measured load of the canopy, i.e. we've multiplied up the pressures that are in the springs. And you can see that quite closely follows the temperature. So the fluid in the springs is expanding and contracting. And then we've plotted out that load for each of the columns in place on the graph. And you can see that each of those columns is behaving slightly differently. So the red graph here is just showing the load in the columns. So you can see by the position of the red line for each of the columns how the load is distributed across the canopy, which is somewhat smoother than you might expect for something that's just behaving as a rigid plate on pin supports. And then the blue line is just the difference in load, which is zeroed from the beginning. So there are some things you can note. Firstly, that those corner columns, the load is changing more than the ones in the middle, and that's because the canopy is bowing up and down. They're tending to move more and distribute the load. The second is you can actually see the phase of the corner column change in load is opposite to the phase of the interior column change in load, and that's because the entire canopy is bowing, the corners are moving down whilst the inside is moving up. And then also you can see the shape of some of these curves is slightly different, indicating slightly different behavior in terms of friction that's going on in the column heads. Some of those are forming like a sawtooth pattern, but some are following the temperature curve more precisely. And then plotting the same curve a year after, when the PV panels have been installed, you can essentially see that over a fairly similar period of days, the difference in loading is significantly reduced and the canopy is behaving more kind of as one, moving up and down, rather than having that banana ring effect. I'm going to skip over the rest of mine, but we're going to, well, we have looked at, for example, high winds and how much impact that has. We've looked at some moderate seismic events that have occurred in Athens and the effect that those have on the canopy. And then, importantly, we're establishing a baseline for this novel structure and how it's behaving over time. So when someone comes along in, say, 40, 50, 100 years' time and says, well, the canopy is behaving in such and such a way, is that normal? Is that how this novel structure was behaving when it was built in, say, 2015, 2020? They now have that body of evidence taken from all those sensors that are embedded within those sprung column heads to say that it is behaving as you might expect. So just jumping to the final slide, in terms of what we kind of hope for the canopy architecturally, we've got this sort of really rich history all the way from self-build and yachts and small structures through to iconic architecture that involves ferrocement. And we very much hope that the SNFCC and the canopy that crowns it sort of become part of that architectural language and show what ferrocement can achieve. Thanks. I think we've got precisely 1 minute for Q&A.
Thank you, sir. Thank you very much, both of you, for very composed and insightful presentation. We will open the floor for the question answers now. Any attendees from online, you may unmute your mic or you can write in the chat box. Any questions in the audience? Yes, please.
Can you please brief about the fire rating of this panel?
I didn't quite get the question. Could you repeat that, please?
Fire rating, how much fire retention it can take up?
Did you say fire?
Yeah.
For the canopy, there wasn't a requirement for it to have substantial fire resistance because of being an outdoor canopy. So that actually wasn't a particular concern in the project.
Well, normally with this thin section, how much fire retention it can take up if it is a closed structure?
Well, I think on the fact because it's a roof, it's not if it's a floor structure, I think we would have had to do fire tests. You know, if it's a floor structure in the op house, we absolutely would have done fire tests. As an outdoor canopy, that actually wasn't required in this example. So I guess it's similar to if anyone else on the call has done fire tests and ferrocement elsewhere. I think we also have another question in the chat. The polished light finish seen for the canopy. Can you comment on the finish? Yes, of course. So there's a few key things here about achieving that finish. Number one was using curved steel formwork So when the big panels were precast, it was done on 2mm sheets of steel, which were curved to the shape we wanted. So that panel cast was then laser scanned after it had been cast with a sort of a 3D laser scan to ensure that the surface curvature was within 2mm of what was required. So that starting point was really good structural geometry. But then the finish, it was a high build epoxy paint coat. So I can't particularly remember the name of the product, but it was a high build epoxy. So it could give some additional, let's say, sort of durability, protection against the weather, against carbonation and so on. But also it could then be getting the mirror finish with the sort of as almost like an epoxy. It's a proprietary epoxy paint. Hopefully that answers the question in the chat. It's quite shiny. Yeah, actually the biggest challenge doing the splices between the panels, because of course you line the panels up, you got to then mortar that by hand to get the smooth curvature. So that became down to the real skill of the workforce, many of whom were traditional Greek building renderers. And then really 100 of them, in fact, developed their skill set in ferrocement production and achieved an amazing quality. That's testament to their craft, really.
Sir, there is one more question from Engineer Amit Shirke. Thermal stress of ferrocement layer due to external radiation. Would you like to give some
So we carried
comments?
a lot of analysis and modeling of this in the design phase and working out the difference in thermal gradients and thermal differential, which could be the thing that creates the thermal stress. If what we found quite quickly was actually, obviously, sun on the top skin, solar gain, that through the thickness it would heat up relatively uniformly through the thickness of the skin and the ribs of the top skin. But then the main differential was the top skin would be hot and the bottom skin, 2-3 meters below, was much colder. And so that was the major concern, that then if you've got a hot top skin and a cold bottom skin, it bows. And that was really the key mitigation, was the soft columns that David described, the sprung columns, and then the monitoring to understand how is this working. But actually the thing we didn't very much time for was the fact that as we monitored, during that monitoring phase, the solar panels were installed because the structure was finished. We began monitoring, and then 6 months later, the solar panels went on. As soon as the solar panels went on, despite the fact they're black, and you might expect it to, have some unusual thermal effect, it actually had a huge benefit for reducing the differential thermal effects on the ferrocement underneath.
Thank you. Heartfelt thanks to Engineer Pete and Engineer David for this presentation and answering the questions and joining this international conference. Thank you so much. We will now proceed to the next session.
Thank you very much for having us.
Have a nice day, sir. Now we introduce one of our key industry supporters, Ultratech Cement. I request Engineer Sandeep Bansal to kindly brief the presentation.
क्लोज पण होईना ओपन होईना झालं ब्राउझर करा क्लोज करू शेअरिंग स्टॉप करू शेअरिंग स्टॉपच आहे शेअरिंग ऑन नाही आहे फुल स्क्रीन करायचं आहे कशात नको ॲडॉबमधून चालते ना दिसते की बघा ॲडॉब इससे आगे पीछे ना ये नीचे ऊपर ठीक
Good afternoon, everyone. On behalf of Vishal Kulkarni sir, today I am going to present this product presentation of Ultratech Cement. First of all, I would like to thank Ferrocement Society and Bnca College for giving us the opportunity to do this presentation. Now I will go through this presentation.
not responding यायला कंट्रोल ऑल डिलीट कर कशात ओपन करू राईट क्लिक पुढे जाऊन ॲड शेअर केलं का कर इसका पीपीटी रहेगा क्या सर पीपीटी लैपटॉप में रहेगा पीपीटी बड़ा था इसलिए भेजूँ कैसे आपको वैसे ही दिखाता हूँ कुछ नहीं वैसे ही दिखाता हूँ
One announcement, kindly pay attention. There were some few books which were there outside on the stall by Ferrocement Society India. So if anyone has taken those books, those are for sale, just not for the reference. Kindly give it back to them. Repeating that again. So there are some books kept on the stall of Ferrocement India. So we have got those books inside, some attendee participants. So I request you to give those books back as those are for sale.
नेक्स्ट कसं करणार हे लका सोडा सोडा हे काय नाही ना तसं एवढं प्रेझेंटेशनला असेल सर अडकचं काय सर आणि फुल स्क्रीन दिसेल का ते दिसेल ना एक मिनट फुल स्क्रीन अब देखो ये गया पॉइंट ये आ जाएगा यहाँ
Good afternoon. I am Sandeep Bansal. On behalf of Vishal Kulkarni sir, today I am going to give the presentation of Ultratech building products. What are the services we are offering? And I would like to thank Ferrocement Society and Bnca College for giving us the opportunity to give this presentation. Aditya Birla Group is a diversified group. It is not only in cement but also in carbon, cellulose, chemicals, digital platforms, dining experience, entertainment, fashion, financial service, insulation, jewelry, metals, mining, paints, real estate, telecom, trading. So these are the businesses where Aditya Birla Group is doing. For cement, our vision is to be the leader in building solution. The group vision is to be the leader in building solution. And today we have 34 integrated plants, 8 bulk terminals, 34 grinding units and 5 jetties. Installed capacity we have 192 plus million ton per annum. We have right now this capacity we are having 192 plus million ton per annum. We have started cement in 1983 with 1 million ton. Now we are at 192. We are the leader in cement. Globally, we are on the third, excluding China, and in India, we are on the first. In white cement, we are the leader in white cement. We have started our plant in 1998. Ready mix, we started our business in 1998. And we have, right now we are having 395 RMC plants and across 155 cities. We have building solution, a one-stop solution for our retail customers. Right now we are having 4,400 plus stores across 22 states. And also we are having a 50 plus building products which are IGBC certified. These are some of our legendary project association where we have supplied our RMCs, our cement, our products. These are some of the legendary projects. In metros, we are providing cement, our RMC, our products, in Delhi Metro, Bangalore, Kolkata, Hyderabad, Nagpur, Lucknow, Pune, all of the metro across India, we are providing our services, our cements, our RMCs. These are the commercial products where we are providing in Panchsheel IT Park, Pune. These are some of the iconic structures where we are providing our cement RMC products. In Pune, we are providing OPC 53 grade Birla Super Cement, and in across India, we are giving PPC. Both the cement we are given in Pune market. This is the only cement where we get Green Pro certificate by IGBC for our Ultratech PPC. These are some of the other products we are having industrial grouts, repair product, flooring screeds, plaster products, waterproofing products, AAC blocks, tile adhesives, mortar. You can see we are going to what are the product we are offering, what are the services we are offering. If we want deeper information on that product or the technicalities of the particular product, so we have installed our stall at the ground floor. You can visit the stall and get the technicality of that particular products. So BPT products are the green products. They are durable and sustainable, ready to use, consistent quality, faster completion, conveyance आपका easy to use, उस type से ये products हैं. So these are the products. In plaster and mortar we are having 4 to 5 products. In tile adhesive we are having 6 products. Flooring 1 product. Grouting 6 to 7 products, and in waterproofing near about 7 to 8 products we are having. So we see one by one. This is a tile fixo product where the jointing mortar we can fix the blocks. We can fix the blocks by using this product. So the compressive strength of this product is around 6 to 7 Newton per mm square. This is the super stucco. No curing is required. Just you have to mix the water 25% by weight, and you can apply as a putty. 3 mm you get the plaster, but you have to apply on blocks or on concrete surface. So very thin layer plaster and no curing is required. Rest all the product you have to cure at least 2 to 3 days, 2 to 3 times a day. This is the ready plast. You have to mix the water and do the plaster on blocks. Is a solution to conventional plaster. You can apply this on the blocks, and more the coverage you get if you apply on red or fly ash bricks. So the coverage will come. So you will get the lesser coverage if you apply this product on red bricks or fly ash bricks. So this is the product. This is the you get the you have to do 2 to 3 days curing, and the compressive strength is about 8 to 10 megapascal. This is a base kit product. This is a base kit where the multi-purpose mortar. You have to mix the water by 25% by weight, and up to a 25 mm by thickness. You do the plaster in one stroke. So and see the strength of this product is around 20 to 25 Newton per mm square. So this is the Ultratech Smart Top. Where this is the hardener. This is the hardener where the flooring work you have to give more strength. So this is the hardener where you have to sprinkle the powder on the fresh concrete and do that finishing work. The 6 mm of the top layer will get more strength for the movement of the heavy vehicles. These are some of the waterproofing products. Let's see one by one. This is the Ultratech Weather Pro. So this is basically the integral waterproofing. It reduces the water cement ratio. It improves workability, reduce permeability, and definitely it increases the strength of the concrete or plaster. So this is the integral waterproofing product we are offering. This is the Seal and Dry. There are 2 component product. The liquid form and the powder form you both have to fix and do the brush application for the swimming pool, for the tanks, for slab work, So this is a brush application product. So you have to do the if you want more technicality of for the particular product, you can visit our stall and you get from there only. So this is a sealant dry, Ultratech sealant dry. This is a bonding agent product. We use this product as a bonding agent. We use this as a product waterproofing agent. We use this as a polymer modified mortar. We use this as a polymer mortar concrete. We use this as polymer mortar plaster. So all this work can be done for this product. This is a sealant dry 5+. This is again bonding agent, polymer modified mortar, polymer modified concrete, anti-corrosive rebar coating, crack filling, where you can use this product. Ultratech sealant dry 5+. This is a B2 Pro product, Ultratech B2 Pro, where you have directly do the brush application from plinth level, जहाँ से ग्राउंड वाटर का हाई राइज होता है और हमारी बिल्डिंग्स पे आता है, तो वहाँ पर आप इसको यूज़ कर सकते हैं प्लिंथ लेवल पे, तो वहाँ पर आपका ये वाटर प्रूफिंग हो जाएगा. This is the Ultratech bath light kit. is a kit where whatever the products are required to do for one bathroom, you get the products in one kit only. You not need to purchase different products from different shops, or you have, this is a kit where you buy the kit and you got the bathroom, you all got the waterproofing products in one kit only. This is a top shield product where you can directly apply the brush application for the slabs. We have in 3 colors, white, grey, terracotta. It also reduces the temperature of the building near about 5 to 8 degrees. So you have to do the brush application on the open slabs. This is a power grout we are giving, NS1, NS2, NS3. These are 3 types of power grout we are offering here. So there are 2 types available, flowable and normal. So NS1 strength is around 100 megapascal, NS2 is 80 megapascal, and NS3 is 60 megapascal. These are the, and basically grouts are used for the anchoring of the bolts. So we are giving NS1 in Pune Metro here. So these are Ultratech power grout gun motor where we have to fill the small gaps by the gun. So this we are having. Most of the products are IGBC certified. So these are near about 35 plus products we are offering IGBC certified. Now we go to for the RMCs. So we are having whatever the type of construction, whatever the type of client requirement, we are offering that type of concrete. So we are having different type of concrete here: decorative concrete, advanced structural concrete, durable multiplier, floor and slab concrete, and repair concrete. So whatever the customer wants, whatever the clients wants, we are providing that kind of concrete for their particular structure. So if we see, we are Ultratech Dicor is the decorative concrete, stem concrete we are offering. Stem concrete अगर किसी को रहा तो उस टाइप से भी हम लोग concrete अलग अलग कलर्स के हिसाब से हम लोग ऑफर करते हैं. This is the polished concrete Ultratech Mksss floor concrete. We are this is a finish. Mksss we are offering the floor concrete. This is a Dura facade, everlasting beautiful facade. For the aesthetical view, see the strength of the compressive strength is around 120 to 130 megapascal, and flexile strength is 18 to 20 megapascal. So we are offering this also through our RMCs. This is the pervious concrete where water can percolate to recharge the groundwater table. We are offering here. Now we go to advanced structural solutions. We are offering AquaSeal, reliable waterproofing with self-healing concrete, sealed water sealing, the concrete where the water does not percolate from one point to another. So we are offering with guarantee and warranty. This is the Thermocon Plus, the concrete that control the core temperature. अंदर का जो temperature है वो हम लोग control करके देखते हैं कि thermal correction आए concrete में. So that we are offering through our RMC. This is a self-compacting concrete which flow freely and compact on its own. So ये भी हम लोग देते हैं. This is a Ultratech Fire Safe unique concrete that resists fires. अगर कोई बिल्डिंग में एग्जांपल आग लगती है या जनरली फायर गेट ट्रांसमिटेड फ्रॉम वन फ्लोर टू अनदर थ्रू डक्ट्स, थ्रू इलेक्ट्रिक डक्ट्स. सो ये कंक्रीट हम वहाँ पर देते हैं डक्ट्स पे लगाने के लिए, डक्ट्स पे यूज़ करने के लिए, ताकि एक फ्लोर से दूसरे फ्लोर पर ट्रांसमिट ना हो पाए कंक्रीट फायर. So this is the durability multiplier. This is the Ultratech DuraPlus concrete we are offering. Triple advantage concrete with superior quality. In this we are using fibers to improve the shrinkage, resistance, permeability, etc. This we are offering for RMC. This is the Coroprotect concrete. This is a Coroprotect concrete against corrosion. So this we are offering. Slab for floors and slab solution, we are offering I-floors for industrial floors. This is the concrete we are offering. We have Lightcon, lightweight concrete, we are offering through our RMC. Small repairs, we are offering rapid. कुछ छोटा काम है, जल्दी करना है काम को, उसके लिए rapid concrete भी हम लोग दे रहे हैं. And we are offering bucket और zip concrete through कुछ छोटा काम है जहाँ पर पूरा TM नहीं जा सकता है. We are offering in buckets also concrete. This is the mobile concrete expert we are giving to our IHB customers. We are giving concrete cube testing, cover block, silt content, slum, fineness, water testing. So these are the services we are offering to our IHB customer, individual house builder customer. So we are providing this services to our customer also. Thank you.
Thank you for that interesting presentation. Here I take a moment on behalf of organizing committee, Dr. Bhanuben Nanavati College of Architecture and Ferrocement Society India, for our industry partners, Vascon Engineers as well as Ultratech. I thank the industry partners along with Mr. Umesh Chavan from KHED to make the, to support the conference and make it a success. I request Kalyan Sundaram sir to come on the stage and present. Kalyan Sundaram sir is our convener of the conference. Kalyan sir, please. After Kalyan sir's session, we will all come and gather at the circular courtyard on the ground floor level. We will have a group photo of all the conference attendees and presenters together. So after sir's session, we will all go down for a group photo. Thank you. Yeah. After the group photo, we can take a look at the exhibition put up on the ground floor level and proceed for the lunch in the same area.
लंच का अनाउंसमेंट कर दिया. So I think how many of you are first time attendees kind of? I think lot of students are there. Yeah, I think lot of you are there. तो सबसे पहले आपके दिमाग में आएगा भाई ये फेरो सीमेंट चीज़ क्या है. सीमेंट बोल रहे हैं. Let me understand what is this ferro cement, right? So I'm going to start for, as I told in the very beginning, KG to PG. ठीक है? So let's say you started off in kindergarten playing with clay and you build clay models. तो वहाँ से चालू करते हैं, लेकिन उसके पहले थोड़ा ये झलक दे देता हूँ. So this is funda which all professors like to give you. It is a society where the researchers, the contractors, the academicians, students को डालना चाहिए था. I should have put students actually, and engineers, government, architects, regulatory bodies all come together. The owner says, I want to build something. The architect and the consultant says, okay, let us do work on this. The government authorities work. And then There are applications in the rural sectors and in the government sectors. Now I come to the most important thing. What is ferrocement? Correct? This question is on your head. So चालू करते हैं. It is a dream material to be used by creative architects and engineers for several applications using curved shapes. Okay, clear? So what is this, sir? Basically, it consists of, you see this mesh, you got wire mesh. ये जो पहले वाला है ना, this is called wire mesh. You see my mouse. And you got steel bars, ठीक है? And then इसको कहते हैं chicken mesh. Why is it called chicken mesh? Because chicken houses are built with this so that they don't run away. Okay, so this is used in chicken meshes. And then ये मिट्टी, this is sand, which is sand. Okay, you know what is sand? This is cement and water. Then this is all it takes to make ferrocement. So we'll go ahead. So then what we have is, I think slide is, how do you, it's stuck. एक मिनट escape करूँ देख लीजिए I don't know अच्छा okay thank you all right. So basically it is simply the skeleton of a wire mesh on which chicken mesh is tied. So suppose you want to build something, first you make, suppose you want to make something like this. You first take the wire mesh. I think you will have a demonstration down which will make it clear. So you see in this video you will find that this wire mesh is first placed. This chicken mesh which you see here is tied on top of this, and then on top of that a rich cement mortar is taken by this mason, and and it's just put on top of this together so that it sticks. That's all. That is what is ferrocement. And what is the proportion? Generally it is 1:2.5, by that is cement is to fine side, and with about less than around 45% water. Now this is basically ferrocement. What is the advantage? No coarse aggregates. You see, there is no coarse aggregate. There is no timber work to make a frame. Clear? Everybody clear? You are able to understand? Okay. Then there is no pouring of cement. You just take with your hand or whatever suitable implement you have and you fill it. Clear? You make a skeleton out of the shape you like, and whichever shape you like, customize it and press the cement. Okay, next. Once you do it and leave it for curing, you get a very sexy shape. Slim section you get like this, which is what is ferrocement structure. Everybody clear? समझ में आ गया? It's that simple. All of you can make it. And you can try in your house also. No need of permissions. All right. घर में कुछ टूट गया, गवंडी को नहीं बुलाने का, खुद जाके ठीक करने का. Understood? Most of the students should remember this. Put up. What is the big advantage of ferrocement? First thing, by that we have some industry partners. I want to tell something after I finish this slide. Lower costs for a wide variety of applications. तो Ultratech बोलेगा यार मेरा धंधा चौपट हो जाएगा. If you say low cost, then are you cutting into my profit? So first thing I want to tell, I think only one industry partner is there. I think Vascon is there. Ultratech here. Ultratech has gone out. Somebody is there from Ultratech? Okay. So what I want to say is, in West Bengal, I am telling a 40-year-old story. They said if computers come, okay, the communists had a different philosophy. Computer आएगा तो हमारा job चला जाएगा. So in State Bank of India in Bengal did not have ATMs and computers for a very long time. They said computer लाओगे तो जो भी computer लाएगा उसको मार देंगे, फेंक देंगे, तोड़ देंगे. As a result, do you think that computers took away jobs? Actually उल्टा हो गया. Computer में ज़्यादा job हो गया, ज़्यादा pay हो गया. Same thing is going to happen to Ferrocement and Ultratech and all those companies who say I'm sorry, I'm not saying Ultratech. What I mean to say is those companies, cement companies typically who say कि if you save on cement, you will save on profit. Sorry, both are two different things. Saving on cement is different from saving on profit. आपका profit बढ़ने वाला है by using ferrocement. All right. Does not need highly skilled labor. Any fool can do it. I have done it. Okay. So I'm saying, I don't mean to say I'm a fool or you are a fool, but basically any fool can do it. Anybody can do it. No skilled labor needed. It can be customized to any shape. I'm going to show you those shapes. Okay. I will say, sir, is it possible? I'm going to show you. Eco-friendly, sustainable materials can be used for innovative designs. Okay, let's see that. What are the applications? इतना सारा है. Sir, ये मेरे को नहीं मांगता है. Picture दिखाओ. So let's go to picture first. Before I go to picture, Ferrocement Society, I think I would like to tell you that this society has been in work for quite some time, since 2005. It was in somebody's head. People got together. I think Lele sir and others will explain more. Always our conferences have been international. So I just want to say, from the day one, although we have operated in India, we have had people from India, Bangladesh, sometimes from Pakistan, I am not sure, and then maybe all other parts, Sri Lanka, Italy, as you have seen a few international speakers. From the day one, it has been an international conference only, and till today we are continuing with the trend, and of course FS 2025 is in Bnca. What are the applications developed? You see this arch face dam, this is one application, and this retaining walls, okay, this is another application. And if you construct such a, if you construct in other methods, you will say, let's say it costs 15 lakhs, this will cost you 7 or 8 lakhs, and this whole structure can be completed. Now, this is spent, now let us talk about chemical resistance. So if you say spent wash digesters of 70,000 liters, something like this can be developed. Can you see this? Then this is a petal tank for storage of water in the rural areas. So you can have this particular petal tank. Look at this. This is in Ahmedabad. How many of you are from Ahmedabad? Any? Very good, very good. देखा है आपने इसको? देखा है? So this is from Grid Architects Ahmedabad. So this is a structure which somebody dreams about. कंप्यूटर में होता है, कंप्यूटर में पिज़्ज़ा ड्रॉ किया, पिज़्ज़ा आता है क्या? नहीं, लेकिन कंप्यूटर में आपने ड्रॉ किया तो हम फेरोसीमेंट में उसमें बना देंगे, ठीक है? Of course, I should not be reminding you of lunch too often. So then we have this Grid Architects again in Ahmedabad. Look at this beautiful structure. This has been built with ferrocement. Then this is the same structure in a different time of the day. Look at this. Nautilus. How many of you have read that book, Nautilus? You see, look at this. This is designed by a Mexican architect, and I think it competes with Sachin Tendulkar's house. All bedroom, I don't know. All right. So look at this particular design. This is the same design which can be built all in ferrocement. Okay. This is also built in ferrocement, the same place that is. And this is Anupama Kundu's, she's an architect, origami, we called it ferrigami. She's one of the awardees. Oh yes, I forgot to mention, for the Ferrocement Society gives awards to all architects and engineers who build innovative structures. Okay. जैसे अच्छा स्ट्रक्चर मिला उनको बुलाते हैं भाई, अवार्ड देते हैं कि भाई और बनाओ. There are a few people here, I think, is there any awardee over here? I think we called a few people. Yes, there are a few awardees of, they are all sitting here, and you can interact with them and understand how to, if you have got questions on this. Now we go to the next thing. Now look at this. There's a bird in New York on Long Island. When was it built? 1931. This technology is more than 400 years old, maybe 500 years old. It is used for boats. Look at this. It's in a tsunami area. So today somebody was talking about strength. Is this dam strong? You can also Armstrong, all right, Neil Armstrong. चांद पे जाएगा भी पता नहीं, एक दिन जा भी सकता है. Let's look at this. You're going to see a structure. We have got Nandakumar Jadhav sir, who's somewhere here. He has built structures similar to this. This is a hotel or a resort. This is used for canal filling. Can you see this? Canal filling applications. And this is for retrofitting old bridge. Lakdi pool gir gaya. London Bridge is falling down. I don't want it to fall down. I don't want to construct a new flyover. I want to repair it. So you can use this material for repairs. Okay. Old culvert. वैसे के वैसे. पुराना वाड़ा पाड़ने का नहीं. उसको वाड़ा में ही रहने का. You understood? So we want to do it. We can do it with ferrocement. Floating hotel. Possible है क्या? Of course it is possible with ferrocement. So there are people who have built floating houses and floating hotels, and it's not just in Gulf. Suppose, we have got buildings where flooding occurs regularly. So there have been 2-3 photos, I think I've got some pictures, where they have built it on, usually what they do, the cars are parked, so you build a house on a boat, and that is on land only, and you put an anchor. So when the flood comes, the house just floats up with your vehicle. How's that? And then पानी गया तो अपने आप नीचे आता है, लेकिन वो घर इधर का घर उधर गया तो क्या करेंगे, नहीं क्या पानी बहता है ना, तो उसके लिए एंकर लगा के छोड़ते हैं. समझ में आ गया? I think all students should have understood this. I'm sure others also would have. So these are applications of all-in-one method of construction. So I think Lele sir and others will explain more on this when during the demonstration. Then we go. These are other applications of all-in-one method of construction, walls, etc., etc. They will explain. Pushyamitra, Dr. Divikar's work is also there in this, and they will all explain all of this. These are the methods of the all-in-one construction. This is a long pipeline which has been done. Water course diversion. Now to zoos, animals. Okay. This is a construction which has been done by one of the Ferrocement architects and engineers, Udayan Soni ji. He's not easy. I don't think he's here. So now you'll be constructing. Hey, shinga kashe karaycho? How do you make these horns, right? Rhinoceros. Anybody knows rhinoceros horns? What is the property of rhinoceros horns? Anybody in this audience? No? Yes or no? Yes. Haan to haan. Yes. You know. Okay, that's good. Made up. That's fine. Any other reason? But what is so great about rhinoceros horns that prevented rhinoceros from being hunted? If you go and say, I'm going to hunt a rhinoceros, you'll be arrested. So I'll tell you the reason. The Ahom kings of Assam, okay, they used to drink wine in the cups made out of the rhinoceros horn. Twin horn. India is the only country in the world where you got a twin horn. एक नाही दोन, बरं का? आपल्याकडे सर्व विचित्र प्राणी भरलेले देशात, ते तुम्हाला माहिती आहे. पण in India you got camels. Camels have in Arabian camel and Indian camel का फरक क्या है? Arabian camel has got one hump. आमच्याकडे दोन आहेत. He is called a dromedary. Okay, that is a typical about Indian camel. तसं आपल्या rhinocerosला एक शिंग नाही, दोन आहे, नाही का? म्हणजे असं so basically they have got two horns. So what they do is this horn they used to drink wine. Why? Because what happens, जो ला पिला दे साकी है, नहीं कि वो गाना है, देखो दारू का गाना होता है. So when this person fills in wine, they fill in poison. Okay, अभी राजा को मारने का है, दारू में मस्त है, उसको मालूम नहीं है, थोड़ा सा लगा के उसको ऊपर कर दो. What happens is, if you pour poison into a rhinoceros cup, that cup will blast. मतलब ऐसा रहेगा, पीते रहेगा, उसमें poison वाला दारू डाल दिया, cup will burst. Like गद्दार कौन है, पकड़ो उसको. तो इसके लिए they used to drink in glasses of rhinoceros horns. Clear? Understood? Now I come back to this ferrocement. So rhinoceros horns are used. Now let us go to this. How do you make this? So first what you do, you make multiple layers of meshes on the ground. Okay, you have seen this, right? Then you build, and the chicken mesh can be curved around. Clear? Have you understood? तो आपको जो shape चाहिए, you can make that sexy shape you want. Then you make it like this. Then you tie it with the steel, understood? With the wire mesh and the chicken mesh, you tie it together. After you tie it together, you put rods to strengthen it. Then you make that whole frame. और उसको खड़ा कर दो. समझ में आ गया? Have you understood? I told you, once you made this, उसके ऊपर सीमेंट मारो, स्ट्रक्चर को सपोर्ट करो. सीमेंट मारने के बाद ये पूरा शिंग तैयार हो जाता है. क्या बात है? You get a beautiful structure which is called as rhinoceros horn or whatever. I don't know what he made it, but perhaps it is ivory, elephant zoo. And this is in Africa. The name of the constructor is Udayan Soni, and he has made it. So I think you have understood how to make rhinoceros horns. Okay, you can try it. Now this is precast housing. It is used. It saves time and money and all this. That is fine. So Mr. Murudkar calls it Jhatpat house. That is the exact word he calls it. And it is in Satara. You can go and see it. Then lost formwork. Again, Dr. Divekar and Dr. Purandari's work is here. I think Dr. Lele, Mr. Engineer Lele will talk about it. These are with formwork and without formwork. They'll talk about it. And this is a check dam in Sangli. Sanglicha माणसं चांगली असतात. Okay, so there's something you can just, if you are from there, you will feel nice. So basically, this is a check dam in Sangli, and this saves water. We have two very nice stalwarts, which is, that is, we have got engineer Ullas Paranjpe, who's built almost more than 1,000 water tanks. I think I think he's sitting there in the audience. Ullas sir, namaste from our side and from the society side and everybody. We have got Milind Kulkarni, who's there in one of the rows, in the rows over here, who is also a stalwart who has worked in this area. He's done a lot of structures too. And this is another example of a check dam. This is an anda which has been made, of course. Usko naam kuch aur diya hai. This is a water quenching cold drink house. Curved staircases. You will be seeing curved staircases. Okay, you don't want. आजकल कोई सीधा चीज पसंद नहीं करता है, तो टेढ़ा ही चाहिए. तो उसके लिए वो टेढ़ा staircase बनाएंगे कैसे? Now look at this very beautiful house. This is built in Florida. It can withstand hurricanes up to 400 kilometers per hour. And this is Nandakumar Jadav's cottage at Mega Cave Center in Y. Okay. Of course, we visited that in the last conference, and there you can see Owen, who is one of the speakers here, and we have got Mr. Patankar there, and we were visited. And now, the same concept can be used to build a boat. Have you understood? When you were small in second standard, you were asked to build with paper, na origami. I don't know what it's. उसका आज बड़े-बड़े नाम हो गया. हमारे टाइम में बोर होते थे तो एक कागज फाड़ने का, बोर मारने का और रॉकेट छोड़ने का, तो आप लोग बोट बनाते थे. तो आप लोग ये we can make a skeleton of a boat. All right, next. So this is a structure of a hangar or a semicircular dome, airport. You call whatever application, बैठने के लिए जगह यार, चाय पीने के लिए कुछ भी. So this is a canteen. You can call it anything. How to make it? Same concept. Do the same thing. Then after this, after you cement it and put it, the panels come. It looks like this. This is a swimming pool. इतना सारा पानी नहीं बोला तो अभी पानी का swimming pool चाहिए ना, थोड़ा entertainment भी तो चाहिए. So this is used for making swimming pools. सिर्फ यही बहुत बात करता है. It is used for temples. It is used for mosques. These mosques have been built in India also. A few mosques. This is from South Sumatra, some other part of the world. But here we have got mosques which have been built in India also. We have got temples which have been built in India. We have got pictures of that too. This is a hyper house of Ferrocement. Of course, what we wish to go further is, now sir, ये सब ठीक है. How the hell people are still pessimistic? They'll say, how does it get all this strength and all that? Okay, so I'm going to talk about it. So एक थ्योरी मैं ज़्यादा नहीं भरूँगा, आपको ऑलरेडी थ्योरी देने वाले बहुत प्रोफेसर है, मैं नहीं करूँगा. मैं इसके लिए आई एम जस्ट गोइंग टू टच विथ यू. What is it that makes ferrocement a very good material? This is also of interest to our industry partners and to other researchers. Basically, you have got steel with cement bonded. So, and it is very finely bonded, and that gives you a lot of plastic yielding to concrete, which is not available in pure RCC. In short, so थोड़क्यात, the crack development and the propagation characteristics change. These are the different parameters. Somebody else will deal with it and maybe encourage you to study it better. These are the ferrocement. Should be designed as ferrocement. I think Lele sir and others will talk about it. Cordless modulus of elasticity. I think all of you know this. Modulus of elastic. I'll make you elastic plastic, so you'll get more hungry. I don't want to do much of that, but I think you'll get hungry after that. We have got publications in this area. Oh, that comes Nandakumar Jadhav sir, and he's. I just showed your photo to the children. So he has come. You bug him after he comes. When he goes for the field visit, you should bug him also. So you should ask him how he built that house, why he made it like this and not like that. You should ask those questions. So then you have got ferrocrete. We have got textbooks and design of concrete structures. And for those who are a bit senior, the state government handbook is available on ferrocement. I think some of us asked about it. Then, ये सब ठीक है. छोड़ो कल की बात पुरानी. चलो, that Hindustani वाला गाना. So let's look about it. What are the other applications? So I'll tell you a very simple application. In this building itself, बहुत सारे कोपरे में मोबाइल का रेंज नहीं आता है. आता है क्या है? Yes or no? No, it doesn't come, right? अंदर भी नहीं आता है. जैमर नहीं है. ये concrete जैमर है. So, in the future, if you have to have buildings where you have mobile range in your house, in every nook and corner of your house, you will need a ferrocement structure. So, ferrocement is a material through which the radiation can pass through and you will get very good Wi-Fi connectivity. Understood? So, this is going to be the future. IoT based buildings for better internet, Ethernet connectivity, and ferrocement is going to be the choice. कल से इंटरनेट जाने वाला है क्या? नहीं, कम से कम 50 साल रहने वाला है. करेक्ट? 10 साल रहेगा, बहुत हो गया हमारे लिए. It is going to stay forever. Therefore, the new buildings will need this compulsorily. High temperature applications. This is an area on which me and Dr. Patankar is going to present sometime. We have worked. Ferrocement is capable of taking extreme high temperatures also. All right. So we have tried it on concrete, and therefore you can build mineral processing and all that. There is cooling tower and process equipment design for which ferrocement is a better material and is going to be the future. So we are working on those areas. Now this is not pure a civil engineering application. This is an application from, you know, सब कुछ चावल और दाल ही नहीं होता है. Means you need थोड़ा लोणचं पाहिजे, थोडं बाकी सर्व पाहिजे ना. म्हणजे other branches have to come together and then you make it. So we need to put electronics into concrete. We need to put chips into concrete, and you know we need to build those structures, and those different interdisciplinary projects will come around. What does the Ferrocement Society aim? We aim at promoting several activities, and some major milestones are seen on the horizon. So for those people from the industry or from the practicing architects, the BIS code for ferrocement has been proposed and is under serious consideration. I think our keynote speaker and the chairman, the Council of Architecture chairperson, Mr. Purohit mentioned, was asking about textbooks. We have textbooks. He was mentioning about the code. We are just working on the code. I understand that in the US also, that code is under some stage. It's not yet fully approved, but here we have taken it to very high levels. We hope to get approval. The VD Joshi Awards for Ferrocement, I think I mentioned it some time back, that we give it to encourage the creativity of architects. So even if you're a student and you build a beautiful structure, please apply. Understood? I think you should try. Okay, next. So this is the code. Yes, I'm done. Sorry. Yeah, got it. So basically, these are the books, and syllabus is done in universities, and there's a need to develop floating structures using ferrocement. Okay. Therefore, in short, माझं presentation आवडलंय की नाही ते माहित नाही, पण you know I just thought I'll just give you KG to PG background. I came up to PG. And I want to ask you all to kindly become members of the Ferrocement Society of India. Okay. With this, you know, I would like to benefit all of you, not only the students, but all the practicing architects to come and ride the boom with us. Thank you for listening. Jai Hind.
Thank you, sir. That was quite engaging presentation. As informed earlier by Dr. Sujata Mehta, we will be proceeding to lunch. We will be having the group photo in the circular courtyard. The lunch is arranged in the square courtyard. Kind request to put on your badges before you proceed to the lunch. And the announcement which Professor Kanchan Atnurkar has done about the books. The central book is missing from the stall, so if anyone has taken it to go through it, kindly return it to the stall. Thank you. We will reassemble here at 2 p.m. sharp, and we will start with the next session. For online attendees, kindly